welcome everybody. Let me see if there are any last minute people who've come in. Great. Excellent. Just checking one other thing here. All right. Thank you everyone for stopping in. Ramon Perez works as an educator, researcher, and data scientist, and he'll be presenting today for this workshop. He's taught Python to hundreds of students with backgrounds ranging from complete beginner to advanced users. His lessons are full of metaphors, quotes, funny pictures, and exercises to make sure students leave his sessions at least with a laugh, a new concept learned, a new Python trick, or all of the above. All right, and take it away, Ramon.
All right, awesome. Welcome, everyone. Can everyone hear me fine?
Yes.
And I want to say there's a bit of echo. And it might be my fault. Okay. Is it better now? Perfect. All right. Welcome, everyone. Good morning, good evening, good afternoon, wherever you are in your side of the world. I'm in Australia. So right now it is 5:04 a.m. So let me share my screen with everyone to make sure we are all in the same page. All right. One second. For some reason, I cannot see the share your screen button or any of the Zoom button. Oh, no, I got it. Never mind. Okay, perfect. Okay, so I should begin sharing now. Awesome. All right, welcome everyone. So I'm going to cover, what we're going to do today, we're going to talk about dashboards. We're going to start building dashboards. We're going to see them first, and then we're going to try to decompose them. So there's an admit, someone here. Perfect. So what we're going to do is we're going to decompose dashboards. We're going to start building them back up from scratch. So the way the lesson is going to work is if you have been able to successfully download the materials, the repo, and get set up with your environment, then please use your computer to do the tutorial. If you have not been able to do so yet, the link is, I'm going to put it over here, actually, in the chat. Okay, so I just put the link in the chat. Now, if for some reason you have any issues with the downloading of the tutorial, there's also a binder button where you can go to binder and it will open up a session for you. In that session, you will have all of the materials and everything you need to complete the lesson today. All right, so let's go back here. Let's talk about the outline for today first. So I'm going to go ahead and walk over a quick introduction to data visualization and a breakdown of the session. And the breakdown is what I'm going to cover now. So I'm going to do a quick intro to data visualization. And then I'm going to talk about why it's important and what can we accomplish with it. Then we're going to have a 5-minute break. After that, we're going to go over static dashboards. And in static dashboards, as I mentioned earlier, we're going to look at a data set. We're going to look at a dashboard. Then we're going to learn about the data set. Then we're going to learn about all of the elements that make up that dashboard. And we're going to build them back together. The intent of the first one is that we're going to build something that's static, something that we can save and send to someone, and they don't need to interact with it to learn the story behind it. In the second part, after the first part, we're going to have a 10-minute break. Then we're going to head to the second part, where we're going to cover interactive dashboards. And we're going to learn how to make components that interact with all the figures inside our dashboards. That session, even though you see here that it says about 50 minutes, this too might take a little bit longer than this one, and this one will be the least extensive one, the last one. We're gonna have a 15-minute break. I might actually make the 15-minute break part of the first big break or the middle break of the session. And then we're gonna have about a 10-minute break, then we're gonna go into deploying dashboards. Then a couple of things to note. This is not a straight beginner tutorial, but I am assuming that you are a little bit familiarized with Python. I am assuming that you have had some experience with it, and that I'm not assuming that you're an expert by any means, but at least that you are comfortable to some degree with Python. Then the goals of this session is to introduce you to a way to that will make you approach dashboards in a more accessible way. So if you like to read from the New York Times or whatever, any news outlet that you like, you see a dashboard that you like, my goal is that this session teaches you how to look at a dashboard, see a picture, decompose it, and then be able to make it yourself. All right, and then creating static and interactive dashboard, that is the main focus of this lesson. The very last bit, we're going to talk about deploying them, but yep, we're going to cover that, but we're going to focus more on the static and the interactive dashboards. All right, can anyone tell me, let me ask everyone, has everyone been able to get the setup going? If you have the setup, would you please say yes? Or put the letter Y in the chat if you've been able to get all set up. Okay, fantastic. Awesome. Okay, Luri, it is possible. I noticed quite a few issues with GeoPandas in several OSs. And if it persists, make sure you use the binder one. Also, if it does persist, make sure that once you use binder, you keep, oh, I have an up. Make sure you keep using it, because if you switch to binder at any point of the session, make sure you keep in mind two things. One, you have to run a cell every 5 to 10 minutes. If it goes longer than 10 minutes, then the session expires and you have to restart it. The second thing is that if you come to binder and you join it here, you will have to do two things. One is you will need to create a data folder, and in that data folder, you should create an interactive folder and a static folder. In those two folders, you should put the datasets that you were asked to download before the session. So if you go to the repo, all the way to the bottom or close to the bottom, you will have a link that says link to the data. Through that link is going to send you to what Treasure It calls a treasure. And that little treasure has all of the files that we will be using today, all of the data sets that we were using today. And they should be placed in those exact same folders. Not necessarily, but it will make it easier for everyone if they are in those folders. R. Mueller, there is another there is a lighter version of Geoviews, if I'm not mistaken, and I believe it's called Geoviews-Core, and it only installs the essentials of it. So you might want to try that one out. Let's see. Geoviews. Okay, so yeah, it doesn't seem that you have you did the base one. Yes, this one. So try this one if you keep having issues, and If not, use Binder until the first break, and then we'll try to figure it out. Okay. Hi, Mark. So the repo should have all of the files. Let's go back to it. There's 3 notebooks that we need. They're right here, and then you will also need a couple of files that are in these 2 folders, in the dashboard one and the deployment one. If you clone the repo, you can do a git pull, and then that will bring you back the latest changes of it as well. All right, so I'm gonna let everyone to continue getting set up for those of you who are not, and we're gonna get started with the intro to data visualization. I have not posted this slide, or sorry, this notebook with just the intro to data visualization, but I will do so in one of the breaks. All right, so let's talk about data visualization. Why is it important? Why should we care about it? So I love this definition from Tableau, which says like the data visualization is a graphical representation of information and data by using visual elements like charts, graphs, maps, and data visualization tools. It provides an accessible way to see and understand trends, outliers, and patterns in the data. At the end of the day, what the main takeaway from this or from this definition is we use data visualization to derive information, to showcase information, to detect patterns. And there's 3 main ways, which I love to describe data visualization as, or in which data visualization is described. It's perfect to explain, explore, and confirm. And those are 3 of the main things that you get to do with data visualization. So how do we visualize data? Well, there's 2 things. One is that we have 2 kinds of data. One is quantitative and another one is qualitative. In the quantitative one, and I borrowed this chart from one of the most excellent books there are out there called Fundamentals of Data Visualization, a primer on making informative and compelling figures um, by Klaus O. Wilk. Is freely available online, but you can also purchase a hard copy. So when we talk about data visualization, we're visualizing data, we're visualizing information, and that information might come in different ways. Some of those are quantitative, some of those are qualitative. When we speak about qualitative, we have two main types of data, and one is nominal, where we have quantities, but not necessarily numerical in a sense, but they don't have an order per se. For example, here we have the example dog, cat, fish. The dog doesn't come first, before cat, and vice versa. And then we have another kind of categorical encoding or categorical type of data that is ordinal. And ordinal does, as the name implies, specifies order: good, fair, poor, hard, medium, cold, second, third, fourth. Then we have date, we have text as well. Text is mostly considered unstructured data. And what we think of when we think of date, when we think of categories, and when we think of numerical values, usually we think of them in a way in which we see data in a tabular format. So data that you would expect to see or expect to find in a spreadsheet or in a grid like. And when we think about the others, when we think about text or when we think about images, we think about a more unstructured format. All right, so we have data, and now we want to encode it into a kind of information. How do we encode it into that information? Well, we got to ask ourselves a couple of questions when we do. Do we have more than one variable? Are we trying to visualize the price of something versus the amount of years that it has been on the market? Say, if we're thinking about houses, are we trying to visualize the quantities? How many times have something happened? If so, is that order? Is it not? And then we get to derive, as we ask questions about the kind of data we have and the kind of information that we're trying to expose from the data we have, then we end up going through a hierarchy of images and a hierarchy of visualizations that will help us explain our point better. So as I mentioned, I'm going to share this notebook, which I haven't put in the repo yet, in just a second. So then we have the data, we have the types of data, we have the hierarchy of decisions that help us make a better decision. But then when do we select a static visualization versus a dynamic visualization or an interactive visualization? And the way I like to frame this question in my head is, do I want the user to change the story as they go? Or do I want them to see the story that I want to tell them? And that is, in a nutshell, the way I ask myself when I'm about to make a visualization. Am I sharing this with someone? If so, do I want them to see a different kind of story, however they want, or do I want them just to see the story that I want them to see? So here's a nice static visualization. This is, I believe, a visualization that won an award from the South China Post, and it was right after Crazy Rich Asians, the movie. And just explain it's not a visualization in a way that you see your graphs and your bar charts and your line charts, but it's visualizations that gives you a fact or that gives you a number as you interact with it. And we will be creating those big numbers at the bottom today. So in this one, the intent was for the user to actually change the story as they were interacting with the visualization. All right, some do's and don'ts. I'm going to skip this part. So I'm going to go straight to the do's and don'ts. So for the do's, label your axes where appropriate. If you have a title that is very well structured and says exactly what's in the axis, you might not need to put the labels in the axis if it's very self-explanatory. If you have the United States, if you have Japan, if you have Australia, if you have countries in one of the axes, then you might not need to put right next to it, these are the countries. If you have years or if you have times of the day with, say, for example, 7:50 p.m., then you might not need to put, hey, this is an hour because it's already explicit. So where appropriate, label your axis. Add a title. A title is almost always one of the most important things. Use color appropriately. There's three kinds of color, which are sequential, divergent, and categorical. And in this instance, this will be considered categorical because you have different kinds of colors coloring something different in the visualization. Other ones, very popular ones, especially for what is considered choropleth maps, which we will be creating today, are called divergent, and they go from one color to another one. Sequentials are the ones that they start at one color, have a stopping point in the middle, and then they go to another color. And we're going to see examples of that. Here's another very nice use of data visualization to tell different stories, and a very creative one. And now I don't want to focus too much on the don'ts, but some of them are very important and difficult to not touch on. So for the first one, don't use too much color or be careful with the color that you're using. If it's not adding to the visualization, then you might not even need to use it. Make sure you have the appropriate percentages. So if you have percentages in a visualization, make sure they add up to 100. And if they don't, that you explicitly say why they don't. Don't try to put everything in one graph. Make sure your visualization makes sense and it has enough space to showcase the things that are around it. And one second, I am okay. Mine. Try restarting now. Trends. When you use lines, make sure you have time in one of the axes or years or some sort of meaningful encoding or meaningful data point or data type that does go well with a line trend. If you have categories, it gives your user or it gives the person reading your visualization the impression that you are using that there has been a movement from point A to B to C to D, in a direction that there hasn't really been any point. We will be creating a chart similar to this, but not with lines. Don't make your charts unreadable. Don't make no sense. Don't deceive the audience with different intervals in the axis. If you are not starting at 0, either say it or make it very explicit in your visualization. There will be some visualizations today that we will be making that don't start at 0, but they are explicitly, you can tell why they are not starting at 0. For example, prices for houses or prices for renting hotels or renting Airbnbs are not, you're not going to find a price at 0. So that axis already, it cannot start. It could start over there, but it won't start over there. And then, yes, the axis betrayal is probably one of the most common ones, when you don't start at 0, but there's sort of like, you're trying to drive a message behind it. There's a meaning behind it, but it doesn't help your users understand it. So that's really it. A quick intro. So we have data. We have a hierarchical way of asking questions to determine the best visualization. Then we have an encoding. And then in that encoding is where we put our lines, our bar charts, our points, our dots, and on top of those dots, then we put the colors. So we go building layer after layer after layer after layer, and the data is an encoding inside those layers. All right, so now let's head to Binder. Has everyone been able to, if you still remember, if you get into Binder, remember to upload the data sets to the session, because they will not be in there. Okay, then head to the notebooks after you download them and click on 01 static auctions. All right, perfect. So let's talk about our very first dashboards. Let's get to it right away. We got a lot to cover. So what we're going to cover in this session. So we're going to cover the dashboard. We're going to talk about the scenario, why I picked it, for what are the use case of it, the data that we will be using, and then we're going to start breaking the dashboard down. And at the end, we're going to put it all together. There's going to be some exercises along the way, so get ready for those. All right. So the first thing is all of you should have the access to the very first dashboard. And so I had already built it. And what I wanted you to see is that if you see a dashboard in particular that you like, there shouldn't be any reason why you wouldn't be able to put it back together. And the housing market has been quite interesting, especially here in Australia. And even though this is not the most accurate data set, I get curious about not necessarily house pricing data, but house pricing auctions. And this is what this data set covers: house pricing auctions. So let's talk about the dashboard for a second. When you think about giving someone a static representation of information, a static representation of data, you usually want to think carefully about the message that you're going to convey. Usually, one of the some of the most useful pieces of information to provide someone are the main statistics of a dataset. So what are those main statistics in a dataset? Those might be, in particular for houses, you might be interested in, okay, what was the price per bathrooms, rooms, car spots, the type of house, whether it was a townhouse, a duplex, a unit, or a regular house. You might be interested, if you have an entire range of data, you might be interested across the board. What was the minimum price? What was the 25th percentile, the median, the 75th, and the max price? So your distribution or your cutoff points, or your interquartile, the max, the mean, and the median of those points. Another thing, if we are talking about houses, we are talking about suburbs. If we're talking about suburbs, we're talking about locations. If we're talking about locations, we certainly could use or would appreciate to have a map in the visualization. And also, not necessarily a map. If we have 2 years to contrast the data from, or to contrast the data, then we might want to see how have the average price or the median price of 1 year versus the other have changed for the amount of data we have for the time range that we have data for. All right, so we're going to try to deconstruct all of this, or we're going to deconstruct all of these charts, the map, the dots that want to be bars, and then all of these bar charts, and this right here, these big numbers here, which we will get to the name of them in a second. All right, so let's talk about the scenario. So an analyst, an economist, a real estate agent, anyone, normal people like ourselves will be interested in the prices of houses, especially if you are at a point in your life in which you are thinking of purchasing a house. So for this particular data set, it's not the most up-to-date, but it comes from a company that does have auction prices. They list them daily. The name of the company is domain.au, and they are one of the biggest real estate information providers in Australia, not just for renting, or sorry, not just for buying, but also for renting. So on a daily basis, there are auctions all around Australia for houses, and this one in particular was in 2016 and 2017 in the metropolitan city of Melbourne. And so the use cases: somebody trying to find a home, an analyst trying to understand the housing market, a real estate agent wanting to find a hot sale spots to look for the next property to buy. So there's many more cases of why somebody will want to see a house. So those are just some of the ones that I could think of. All right, so I mentioned the data comes from domain.com. Oops, and that link is not there. And yeah, so they do regular releases daily. And here is the information that got collected. This one in particular, this data set was published in Kaggle, and it was scraped. And the last time it was updated was in 2018. I cleaned it a little bit and made a few things to it, because the goal of today is not necessarily to focus on the cleaning of the data, but focusing on the visualization of it and putting insights into images and charts. Here's a breakdown of the variables that we have in the dataset, and we will see a little bit more about them in a second. All right, so the first thing we're going to do is we're going to get that path going for us. And let me ask everyone: has anyone here used pandas before? Has anyone here used? Okay. Perfect. Has anyone here used any visualization library before, like Matplotlib, Seaborn? Okay, awesome. All right. Excuse me. We are not going to use Matplotlib or Seaborn, but it is very helpful if you have used those before. Excuse me. All right. So the first thing we have, we're going to get our path to the data, to where the data lives, because there's a couple of folders there. Then we're going to read our first data set, which is the auctions in Melbourne. We're going to examine it, look at the first couple of rows out of the entire data set. And as you can see, we have quite a lot of information. The postal code, the car spots, the land size, the building area, the year built, date sold, and so forth. We also have a few additional variables, like is month start, end of the quarter, is year start, and so forth, that I added additionally. We can also look at the information to try to understand if there are any missing values in our data set. There are, in particular, in two variables, which we will not be using, but we do have a few additional missing values in the building area and in the year built. You can also see that we have quite a few different kinds of data types. So the numerical one will be the float. Integers, an integer might actually represent a category, just as it might represent an actual numerical value. And then we have a couple of Booleans, which are the ones this is year end, year month, and so forth. You can also check out the missing values or the percentage of missing values that you have by taking the sum of those values which are missing, dividing them by the length of the rows in your dataset, and multiplying that by 100. All right. In addition to that dataset, we also have a geodata frame because we want to be able to map geographical information to some of our visualizations. So what we have is a dataset from the suburbs of Victoria, the state of Victoria, which is the state where the metropolitan area of Melbourne is at. And what we have here is this one is already a pre-processed one where I already took the liberty of getting two things. One, some descriptive statistics of the main data frame, and then combining them with our regular data frame, or sorry, with our geographical data frame. So what does this mean? When you see what you see here, where it says polygon, and then a ton of latitudes and longitudes, what that means is when you have a polygon is that you have some sort of shape. And for the border of that shape, you have a combination of two dots. You have longitude and you have latitude. And that combination makes up a bit of a square. And we can see the information of this data frame. It doesn't have any missing values. It has 4 numerical variables and then 1 integer, the one with the count. So this count right here wouldn't necessarily be considered a category, but it's still an integer. Also, a geodata frame actually allows you to plot its shape immediately with it might not be a big figure. I mean, you can make it a big figure by resizing it, but you can actually select, just make plots by calling the plot, and it will pandas or geopandas will immediately go to the polygon column and then select whatever shapes it has in there to try to plot them. You can also select a specific, let's see, suburb. You can select a specific location or a specific index. So for example, if I say the first one and I pick the suburb, or not the suburb, let's do that plot. Geometry. So I might have forgotten about that one. Well, you can do the plot. We're going to check out how to use these ones here in a second. All right, so let's talk about the tools that we're going to use today. So we're going to be using pandas. We're going to be using geopandas. We're going to be using bokeh, but not necessarily directly. We're going to use bokeh and matplotlib under the hood. What does that mean? That means that we're going to use a tool called holoviews that is a wrapper or sort of an API on top, or a library on top of bokeh and matplotlib. That means that you get to use both of those visualization libraries to your advantage. We will be using mostly bokeh, or I want to say we will solely be using bokeh as the backend of holoviews. But we'll be talking about how they both help us make better visualizations. We're also going to be using Geoviews. And Geoviews is essentially holoviews with an additional Geoviews with an additional capabilities for making geographical plots. The last one that we're going to be using is Panel. Panel is the visualization tool that is going to, or the tool that is going to help us build these dashboards, put all these dashboards together. All right, so let's go ahead and go through the breakdown of what we're going to be doing. Okay, so let's talk about, since we have our dashboard and we have an entire frame. We have this gigantic rectangle, and we're okay. What is this thing composed of? This is the first step. When you look at a dashboard, what is the frame? Or you can start visualization by visualization, but you can also start from the bigger picture and you say, how are all of these pictures put together? How did they assemble them all in one place? And the way we do this is with the library called panel. Panel has three main things. One is called a pane, another one is called a widget, and another one is called a panel. Through the panel one, you have your containers. These containers are sort of what you use to put your visualizations under. You can, and they have extensive functionalities such as controlling the width and the height, the background color, the policy with which they stretch. So for example, what does that mean? The policy with which a panel or an application stretches. What that means is that if I go to a website and I open a dashboard in a website, and I resize that website, will it be responsive to the resizing? Will the image get smaller and smaller as I reduce the size of my screen, or will it stay in the same place and it will only give me a bar, a scrolling bar up and down so that I can get to the point that I want to see? So that is how good the fine tuning of this tool is. A widget is the tools that allow you to create interactivity between different measures, between different columns and or different values, and your visualizations. A pane provides a ton of other functionalities, such as markdown cells or strings or selectors. And all of these three can be combined into one. So a panel can hold more panels, can hold several widgets and several panes. And a pane can hold a widget. So, all right, so the three main components of panel are rows, columns, tabs, and grid spec. There are two, we're going to be using for these dashboards rows and columns, but there are two exercises in which you are free to create, in which you are asked to create a tabs object, and another one in which you are asked to create a grid spec object. And with the grid spec, it's sort of if anyone here has used NumPy before, it is, or even regular Python list, it is as if you were creating a nested list of two levels or a NumPy matrix or a pandas data frame. So you have locations that can expand, and you can assign to each one of those locations a specific component, a specific chart. So it's very useful, very powerful. It gives you a different perspective when you use the rows and the columns to get a finer representation of your dashboard. All right, so some of the most important things that you should keep in mind, and I didn't put the definitions of this one because I thought they were self-explanatory. So the background takes a hex color, and you will be using that for, let me run a cell before is, you will be using that, the background a lot. The sizing mode. So the sizing mode has four options or four zones or four categories. You can use sorry. You can use a fixed sizing mode, or you can use a stretch width, which will automatically resize the width of your visualization, or you can use stretch height, or you can use stretch both. So actually those have four. Forgive me, it's about 5:40 a.m. So some of the thoughts still waking up. So all right, the width policy takes precedence on the sizing mode. So if I put a width policy of a stretch width or a stretch or fix, then it will respect it on top of whatever I had put on sizing mode. So that won't even matter. All right, so we'll see more of these ones as we go along, especially align, height, and width. All right, so the first thing, can you also, well, I already mentioned this was supposed to be a quick question about whether you could guess if the dashboard was made of rows and columns, but I already mentioned that it's made out of rows and columns as opposed to the grid spec. But how can we create anything in with panels or with panes? So the simplest way, or the most straightforward way to do so, is by passing in any kind of information, whether it's a text, whether it's a row, whether it's a data frame, whether it is a chart. It will take anything and display it for you. So this is our test title. If you take, you can add markdown like cells or indicators. For example, if you have used markdown before, you remember that when you put the hash in front of a cell or in front of something, in front of a piece of text, markdown will display it as a title. The same happens in your Jupyter notebook when, if you go to the code cell and you change it to a markdown one, and you add a hash, you get to put, this is a title, and you get the exact same representation. So rows do the exact same thing. And here we have a row of one element, or you can think about it as a list of one thing. How do I get, I'm not seeing the out values. How do I get to see them? Could you please describe the relationship between them? Yes, Asim, do you mean Asim? Forgive me if I mispronounce your name, please. The relationship between the rows and the columns? Is that what you are referring to?
I was referring to the panel widget, pane, and containers.
Oh, yeah, absolutely, absolutely. Okay,
Thank you.
so let's go back. Yeah, no problem. Let's go back. Up here really quick. So anything that you want to display, that you want Python to display, or anything that you want panel to display, you can add it to a pane. A pane will take any object, whether it is a string, whether it is a number, whether it is a visualization, whether it is a piece of a data set, and it will display it. What it does is that it says, I'm going to grab something, and now you get to display it. You get to put it on a website, you get to put it on a chart, you get to put it on an application, you get to put it on a dashboard. The widget, on the other hand, the widget says, you have something that I can interact with. You have something that I can pass values in and then get values back. So that's what I'm going to do. I'm going to give you that usability. So the pane, it will display anything. The widget, it would make anything interactive. The pane would be the major container for which you can, that takes panes and panel. Sorry, the panel will take panes and widgets, and it will make a bigger component of all of those. So that's how you can get, so that one takes the most complexity, the panel. It can also take other panels. So a panel example will be a row, a column, and a tab. And a row, a column, and a tab can contain a pane, which a pane can contain a piece of markdown, or a pane can contain a visualization. And a visualization can have attached a widget. And a row can contain, which is a panel, can contain all of those together in one. No problem. Awesome. All right, so in the next one, so now here we have a row of one element, and we added the color blue in the background. We don't need to add the color blue. We can say, okay, this is going to be a red background. In the next one, we can say, we can add 4 things. So here I have taken the liberty of adding the questions that we are asking of every single visualization. So what's the median price per house type? What's the median price per car spot available in a house? What's the median price per bathrooms? What's the median price per rooms? And then I put a background of white. Now, you can change that and you can add it to, I'm not going to put green, but let's see, brown maybe. And then we can also put in brown. We can bring it back to white. And we're going to see later how to change all of these colors in one go. All right, in the next one, so we have another row. And then here I put the bands because those represent the big numbers. Here I put the bars because they represent the very first row that we that we created that's in our dashboard. So our dashboard, these are the components of our dashboard. It has one row with the title and 2 pictures, another row with 4 images, for which I put here 4 questions. Another row contains all of the numbers, the minimum price, the 25th percent of the median, the 75th, and the max price. And then the very last row contains what's the average price per suburb with 100 plus listings, and what's the median house price per suburb, and that will be the map. So those are also 2 of the questions. And then now the very last component making up this dashboard is a column of 4 rows. So notice, now we know that we have one title, but then this title it's not necessarily going to fit an entire row that is going to be composed of 4 charts, or an entire row that is going to be composed of 2 massive charts. So we will have to resize them later on. But to give you a better sense of how we're going to do that, or why this doesn't make sense, look at it right here. We have 4 rows, and that is what is making our big dashboard above, the first one that we visualize. So the title, 4 charts, 5 numbers, 2 charts. How are we going to put that together? Let's work through it together. Okay, so the first one. So what's the median price per house, car spots, bathrooms, and bedrooms in the metropolitan area of Melbourne? All right, if you ever, so remember at the very top, I mentioned that holoviews works with bokeh and it works with matplotlib. And if you notice, when we imported all of our packages, we said holoviews extension, bokeh and matplotlib. The order of these two words matters. When I say bokeh, when I put bokeh first, the first renderer behind the scenes, behind a holoviews plot, will be bokeh. The second one, if it doesn't have a visualization available, will be matplotlib. Now, the next one is panel extension. Panel extension says, I am going to put some visualizations. I'm going to put some containers in this notebook. Please render them for me. The other ones are options for pandas, so that it will display all of the columns, all of the rows, and it will format the high values. Oh, okay. So I guess I should have explained that for anyone that has never used a notebook, and forgive me for that, if you have never used a notebook, there's 2 ways or 3 ways of running code. One is with Shift Enter. The other one is with Alt Enter. That will provide you a new cell below the cell you are in. And then the last one is with the Run command, with the Run button at the top. Those are the 3 ways of getting a notebook to display something. If there is a variable assignment, but nothing underneath it, then it won't express anything in the out version. Control Enter as well. Yeah, I believe, is that one the one that you press Control Enter and you stay in the same cell? Awesome. All right, perfect. So now that we know, we are rendering first with bokeh and second, maybe with matplotlib, if it comes to it. So the very first thing that we wanna check out is we have 4 bars. So no problem, Jason. So we have 4 bars. So how are we gonna make these 4 bars? First off, if we take the default action of holoviews and bokeh and matplotlib, we know that we have to do 2 things. First is where's the data coming from? That's the very first thing, and that will be our very first option or argument. Also, if you ever need help, or if you ever want to see the arguments inside a function, you can also click Shift Tab on inside the object. For example, inside HV bars, if I press Shift Tab, I see the documentation of the object or the type of chart that I'm trying to plot. So notice how it says in the arguments, your first argument is the data. Your second one is your key dimension, which in this case would also be considered the x-axis. So you have two axes, your X, your Y. Your Y will be your values dimension. So the K and the V, or the V is not for vertical, but rather for values. And then star star key WRs means keyword arguments. So we can continue on passing more options. But for now, we want to see the plain vanilla representation that that holoviews gives us. So there's a couple of things to notice. The first one is, one, we have no title. Of course, we didn't specify that. The second one is we have numbers in the y-axis in scientific notation. Third one is, sorry, we have bar charts that don't necessarily look like bar charts. They seem to be like a bar for every number. And if you think about it, var charts are meant to put a quantity. Bar charts are meant to showcase a kind of quantity. And in this instance, we are passing the entire data set for, or all of the prices in our entire data set. So if we were to say, if we were to add a cell above and say, and look at the head of, and look at the first three rows, we are adding every single price that we have in that data set to our visualization. And that's technically, that's not necessarily what we want. So let's check out how can we get to it. When I try to render, I get name error trace by HP bar. Okay, so you have not, yes, you have not imported the previous ones yet. Yes, so all of the, if you go to, not in cell, but run, yeah, if you go to cell and you click run all above, the one you are in right now, that will bring you back to the one you need to be at. It will run all of the cells up until the one that you are in. What that error message is saying, Jason, is that it just hasn't run the command to read in the data frame. All right, so the defaults are not too great. They work, but they sometimes are not the best. So it's not necessarily that we shouldn't trust them, but it's that we need to take a bit better care of our visualizations. So now let's look at what we should do. So the first thing is that since a bar chart is showing the quantity, is showing the values of a given representation, it is using a number that has already been condensed. So for what does that mean? If I have a category such as house and I am trying to show something, well, am I trying to show the average? If I'm trying to show the average, that is one number. If I'm trying to show one number, that is one length for that bar that I'm interested in. And that is why this representation doesn't make much sense. It's not representing one quantity. And if you notice here, we just said price is passing all of the prices inside the data frame. But what we wanted to do is to show the median value or the mean value. So what we need to do is to do a group by operation. What does group by does? Group by says, okay, you have an object here or you have a category and you want to put the entire data frame, you want to split it into this particular category. Once you do that, what would you like to measure? What kind of values would you like to measure? So I'm saying I have three types. I have so I have the, sorry, forgive me. So I have here the type of a house, and I am saying I want to see the house, the townhouse, and the unit price. And what I want to see about them is the median value of all of the house prices, all of the house auction, all of the auctions for which houses were put out for. And in the second one, we're saying, okay, but that's a very high number. How about we say somewhere this number is by the thousands as opposed to 1,175,000 dollars or 846,750. So what we're saying here is actually divide all of this by 100. We have here a group by object. When that group by object comes out with the median, it creates a panda, what is called a panda series. A panda series is a one-dimensional data frame, or a two-dimensional data frame, but or an array, you can think about it, of one column and multiple rows. In the next one, what we want to do is we want to bring out that house over there is considered the index of our data frame. So if you were to think about a Python list will have 1, 2, 3, 4, 5 for its index, but you won't really see it. From a pandas data frame or a panda series, you will get to see the index. When you group by a specific value, those values you group are not the values, but the groupings, the categories by which you group by, they're going to go into the index. So we're going to use the reset index, and we're going to use it a lot today. And we are going to take them out of there and bring back up a data frame with 2 columns and 3 rows. Those 2 columns are, in one column I have the type, in another one I have the price, and then I have a new set of index, 0, 1, and 2. Awesome. Perfect. Since that question I got taken care of. Fantastic. All right. So now that we have the type, so we have the very first visualization that we need. We have this one right here, or we have the data that we need for this visualization right up here, the median price per house. So now we need to get all of the representations for these 4 pictures, or for these 4 charts. So let's head back down. Forgive me, 6 a.m. All right, so that is assigned for the break. So I mentioned that we were going to take a 5-minute break within 30 minutes and completely went away. So how about we take a quick 7-minute break? And it is 6 a.m. my time, I believe is, it must be 4 p.m. your time. So how about we take a 7-minute break? And then we'll see everyone in 7 minutes. Sounds okay?
Sounds good.
Okay, awesome. Just to confirm, what action should we take to make sure the notebook does not expire? Great question. Thank you, Luri. So make sure you run a cell. So you come back to this one, for example, and you run it before 10 minutes have passed. That way your session doesn't expire. Thank you very much. I am on Binder as well. Awesome. So see you everyone in 6 minutes now at 4:07 US. Okay, Jason, would you let me know what do you get in this cell at the very top?
Okay, let me just check. In that cell, it looks like what you have.
Okay. So what about in this one?
Yeah, that's the same as well.
Okay, perfect. What about this one?
That one gives me an input error.
Okay.
Kind of
Have you uploaded the datasets? Have you come to the binder section, and have you created a folder called data?
I'm not using the binder session. I do have a folder called data. And in it is the interactive and the static.
Okay, okay, and then you have the data sets in both.
Mm-hmm. Yeah.
You have in the static one, you have these three.
I'll double check. Yeah.
Okay, perfect. So let's go back to this one. So you have those exact same names.
Yeah.
And when you try to read it, it gives you an error. Would you tell me what the error is?
Yeah. Here I'll cut.
Oh,
and
the
paste
very
it.
bottom of it.
The very bottom, suitable
very
version
bottom
of
of-
Pyro or fast Paraket is
Yeah,
required for
that's-
Paraket support.
That's what I figured that was happening. Okay, so how about this? So change this to CSV.
Okay.
Change the read underscore parquet, change it to read underscore CSV, because you do have two versions of the data set there. You have a clean CSV as well, so that should be fine.
Okay. Now I've got a parse error.
Oh, sorry. You gotta change the parquet at the end of it, and where it says dot parquet, and then
Got
put
it,
dot
yeah.
CSV. All good there?
Yeah.
Awesome. Fantastic.
Yeah. It's I'm just hitting up all the the fields now. So I'm good down to geoframe data, and then geoframe data I'm getting
You getting an error? Were
Yeah.
you able? Is the error about GeoPandas?
see here. No, it looks like driver error. That's weird. Suburbs underscore price dot geojson, no such file or directory.
Not such file there. So wait, so suburbs underscore price. You have this one here,
Yeah.
the static, the path, but then in here, do you have here suburbs underscore price GeoJSON in that?
No.
So that's the one you're missing then. So you gotta download that one from the.
I don't know the whole, maybe the bundle got updated since yesterday. Okay.
So yeah, in the link to the data.
Yeah.
The static one. Yeah, it should be there. And you should be all set up after that. Let me know.
I will. Thank you.
Okay, cool. All right. So welcome back, everyone. So let's continue. So now we have created three representations that we need. We have four charts. We need a representation for each one of those. One of those is, and I didn't separate these ones here, but I should have. So we have a group by object that we call here data bar 3. So we have the data bar 1 with the type of the house. Then we have a second one with the car spots. Then we have another one with the bathrooms. And notice that we have, even though it is sort of a numerical variable, because the amount of quantities that you have, or because the what is called in statistics lingo, the cardinality of that categorical variable is low, we treat it as a category, as a ordinal category, because 0 bathroom is less than 1 bathroom. 2 bathrooms is clearly more than 0, and so forth. So now we have our representation of the average price or the median price in the thousands for the bathrooms and for the car spots. Now you have a quick exercise. Use pandas group by, create a data frame with rooms, take the median of the price column, divide the result from 0.2 by 1,000, and reset the index of your data structure. So that is your task. I'll give you 2 minutes for that, and then we can go. I know that if you're in the binder session, then you're probably going to be able to see the answer. I don't know how to hide it there. In Jupyter Lab, I know that you immediately touch that and it's ready to roll. You hide it, but I don't know here how to hide that. All right, awesome. So if you got the group by and you follow from above, so we needed to create a group by object with the rooms from the dataset. And I am missing here the P, group by object. We wanted to take the price column. And from that, we want to take the median. And from there, we divide it by 1,000 because that's the representation that we have chosen. And we reset the index of it. And if we print this, we have the representation of the rooms inside the house, or inside the house in our data set. All right, so now that we have our data ready, so let's see the difference. So remember, this is not the same data frame that we were using earlier, but rather a summarized version of it. So now it's looking much more like the visualization that we had all the way at the top. Now, some things that this is still missing is the width is still quite high, which is fine. There's no way for us to know that this is actually in the thousands, the price of the house, the median price of a house, of a townhouse, and a unit duplex. Also, we don't have a title. We need to put that title. So, oh, great question. So let's actually look at this again. So notice, so right now I have a data frame with 2 columns. So think about this as an Excel spreadsheet. So we have a data set we have with 2 columns, column A and column B, and then we have the rows on the left. So when we use a group by operator, what Pandas does is that it says that 1, that 2, that 3, I'm going to put it here on the index, and I'm only going to hold 1 column. I'm going to change the index to the number of the rooms, and then I'm going to hold 1 column with the prices. So from here, I took reset index, and notice that now I have as the index the rooms, and as the name of my column the price, the median price. If I add what reset value does, reset values. What reset value does is that it says I'm going to reset. Sorry, not reset. Reset index. What am I doing here? What reset index does is that it says, oh, you know what? I am going to reset the numerical index that is the default for every single pandas data frame or every single pandas series. And unless you tell me to drop the rooms from the left, I'm going to move the rooms to another column. So what's in your index is going to push all of the columns to the right. And now you're going to have 2 instead. Another way of seeing that is that these are 2 completely different data types. So for the first one, we have a pandas series. When we add the reset index, now we have, think about it as our Excel spreadsheet. And now we have a data frame, which will be considered a representation of data with rows and multiple columns. All right, so now we have, I have not run the data butter for, which I need to. There you go. Okay, so here now we have our bar. And notice that this is actually interactive. So we could select these 2 bars and actually, or move it around. That's technically not what we want in this one because we're trying to create a static image. We're trying to create a static dashboard. So we're going to learn here in a second how to put all of this together. All right, so much better. It's looking better. We can also reset the view of that chart and see it back at where it was. But now we need to add parameters. We need to add options. So what we need now is, how do we put a title? How do we add color? How do we reduce the width? How do we customize the axis? How do we make it bigger? How do we make it smaller? How to resize it? How do we resize it? How do we get rid of, since we're going to use a static visualization, how do we get rid of that representation on the right? So this is where the .ops comes into play from holoviews. So holoviews is this combination of these 2 libraries. And what you get to call from those 2 libraries, you use the exact same representations. So the kind of visualizations that you have seen before, for example, HV scatter, you can use, so if you put HV with an S and you press the tab key, you're going to see all of the visualizations that you get to make that start with an S. A Sankey diagram, a scatter plot in 3D, segments, slopes, spikes, spreads, whatever. If you take that S away from that, then you get to see every single bar, every single chart that you get to make with holoviews. Remember that we imported holoviews with an HV. So we can make box plots, we can make bars, which we are using, bivariate charts, curve, you name it. There's quite a lot. There's hundreds. I would say it's got to be close to 100, if not more options here. But you have, the point is that you have a lot of options here. Now, every chart is its own element, and every element has an additional set of parameters. Those additional set of parameters are held over here in what is called ops, which is the options of every chart. Every option is given or is passed after the bar. So remember, up here, we created a bar 1. Now, if we want to customize that bar, we go and say, I want to add some options. And then I want to display this plot. I want to add a title. I want to give it some color. Remember, this is a hex color. So you could go to Google and say hex color picker. And you will find the very first link that you find, you will probably find a hex color picker. So the hex color will be that number at the very top. You can change the view of it, and then you can decide if you want to change the color of the visualizations we're working on. You don't have to, but if you want to, you can. So for example, I could pick this one, and I could come back here, and I could delete this one, and add this new one. And now we have a very odd greenish yellow color. But regardless of it, we have a third option. We have a third option that we're saying, I don't want to see the lines that were here before. So if we take that out, we still don't see the lines. So that's great. So here you see that we have a black line around them. But here is probably with the color that you don't see that. So it's okay. So we're gonna keep the line color to none here. And then what we're gonna do here is, now things are looking much better, but how do we set up those ticks? Because right now, even if we have a title saying the median price per type of house, we still don't have something saying this is in the thousands. So there's no way a house costs $1,000 or $800,000 or $800. So there's gonna be more than that. So what we're gonna do is next is to set up the ticks of the bar charts. And to do so, let's print first the highest number. Once you set the line color to none, you have to change it something else to change it. It will remain. Oh, it will remember the setting you originally set it to. I think you're right. So if you say, for example, if I take this line color from here, but then I come back and I rerun my visualization, and then I come down here with a new color, yes, it remembered the setting. So it is in place, the setting. So good observation, Paul. All right, so now that we have that, so now we have four representations here. So remember, we created 4 bar charts, 4 bar data for our bar charts that hold car spots, bathrooms, rooms, and house type. For all of those, we want to see, we're going to arrange the ticks of the y-axis of all of our 4 charts, and we want to do so in a way in which it makes sense. What would make sense? Well, what would make sense is if we put them all in the same scale. It wouldn't make sense to have one going to 100,000 or 1 million, and then another one going to 3 million in the price. While if we have them all level, then it is easier to read all 4. All right, so now we see that we have 3,425 for the highest price. So we can use plain Python. We can create a range from 0 to the max price of our bar 3, which is 3,425. And we can go in intervals of 1,000. What would that give us? It will give us 0, 1,000, 2,000, 3,000, which for our purposes, that means 1 million, 2 million, 3 million, because we are dealing in the thousands. Remember that we divided everything by the median. We divided the median of the prices for those categories by 1,000. Okay, so now we have bar 1 again, and now we have more options. So we have the title that we had before. We have another color. We're taking the line off. We're making alpha. What alpha does is that it decreases the intensity of a color. So if a 1 being most intense and a 0 being completely transparent, or sorry, 1 being full color and 0 being completely transparent. Now notice that here we created the ticks. Now we are passing to a parameter called y_ticks, which belongs to the options of an element in holoviews. We're passing the y_ticks. And then for the y limit, we're saying, I want you to go from 1 to 3,600. Can anybody tell me why did we put a 1 here for the limit? So if we have a range from 0 to 3,000, why are we putting a 1 here? To not get a 0 tick mark. Right, correct. Because and here's the main reason. When we format the ticks, we format all of them. So if we put 0 or $0 and then a K, is gonna look like 0 thousands as opposed to the actual 0. And if we put it at 1, there's no difference for a house that costs 1 million if there's just $1 there. So it's not a misrepresentation. It's just so that the format that we're going to give the access makes much sense. It makes more sense without a 0. All right, so now we have a lot more. And now the bar is looking much and much better. We still have, so we know that we have median price per type of house. So we shouldn't have to have the price here. We don't need to have the type down here. So remember, the very first rule in the do's, I mean, not a rule, but the very first rule of thumb, I guess, add labels where appropriate. In this instance, we have a title that says we have median price per type of house, and then per type, what type? House, townhouse, unit duplex. So then here we have the price. So we know that we can get rid of those. How do we get rid of those in holoviews? Well, so these are called labels of the axis, the labels of the axis. To get rid of them, we pass in an empty list. That empty list tells holoviews, hey, I don't want anything in those two axes, codifying them. Now we keep the color, we keep the line color to none, we keep the same parameters that we put before, but now we pass in something called Y formatter. The Y formatter says, or does, put something in between the representation of the number. How do you want to display this number? So a $, dot, and 0f in Python is format a float number with 0 decimal places. And then after that, we want a K, representing that this is in the thousands. So if we wouldn't have said that there, we would have to put it on the title. We should have said median price, parentheses, or round brackets in the thousands per type of house. And that would have become too big a title for our purposes. We're also going to rearrange the width and rearrange the height of our bar chart. We're going to disable, remember, we want a static dashboard. So we're going to disable the toolbar. And holoviews provides us a way to do so. Very straightforward. You put the word disable next to the toolbar option. The last thing is that we want to change the width of the bars. We don't want them to be that big. If you recall our dashboard at the top, they were quite thin. So now we have a representation, and that is almost exactly the same as the one above. So, almost the same as the one above. So still not there yet, or sorry, now we are there yet, still not there in the sense that we don't have the same colors that we had above, but we're gonna get to that in a second. Now, if we had to pass, so notice that the options just got quite, it's quite a lot to make a chart that looks different than the default one. So because it is quite a lot, we don't wanna write all of that in every single one of the 4 charts. Instead, what we can do is create a dictionary with plain Python. We can create a dictionary of key value words, of key value pairs, where the keys are going to be the options of our charts, and the values are going to be the inputs that we want to pass on to them. So here we have a dictionary. We pass in the color, the line color, the alpha, the Y limit, and everything that we were just working on. Especially now we took the Y ticks directly, and instead of putting that variable that we created earlier, we pass in the actual range. So now we're going to call it G bar options. So for global bar underscore options. And now what we do is that we create B1, B2, B3. So we're going to create 4 variables. To those 4 variables, we're going to pass our 4 datasets. Those 4 datasets contain the exact same thing, or not the exact same thing, sorry, the exact same representation. Prices by the median price by a category divided in the thousands. All of them have different titles. Notice how now I have opted for adding a slightly more refined title. We can also change that. Instead of putting per, we can put a /, and that also means pair. And here we have the global options. If you have never seen this construction in Python, the 2 stars says unpack a key value pair into its key and its value. So he's saying unpack all of these key value pair options here in this dictionary, unpack them in this container, in this representation. Yes, this helps a ton of time. Now, notice that here we added the width of the bars manually because they will not, because they have different amount of categories, they will be, holoviews will try to resize them as per that so that they don't fall next to the category that they're with. So we add them specifically and we give them a particular width. Now, holoviews provides something very unique and very, very nice, which is, which are two constructs, which are operational constructs, but in the terms of holoviews, it means concatenate or overlay. Concatenate means put one right next to each other. Overlay means put a representation, put a visual on top of another, on top of another, on top of another. In this instance, the plus means let's put everything right next to each other. And now we get a nice representation. So now we're getting closer to that first row of our data set. Now we're getting closer to that first representation that we saw earlier. And okay, so exercise 2 here. Now use a group by method on the day of the week variable. Assign it to my data variable called my data 1. Select the price column and take either the median or the mean of it. Divide that column by 1,000. Reset the index, create a bar chart. Customize it with 5 different options. Actually, that's a lot of options. If you want, just put 3 options. Customize it with 3 different options. Assign the final bar chart, including all options, to a variable called my chart. So remember, here we use a bar chart with our representation, and we assign the options immediately or directly to the variable that we wanted to use. So I'm gonna give you 3 minutes for this one. And 6:30 for me, 6:33. So there is a little hint below if you want to check it out, but you don't have to. Yeah, so I'll give you 3 minutes for that one. Any questions, please let me know. That's another cool thing that you can do with the objects that you concatenate. You can actually surround them in parentheses, and you can add a particular option at the top, either rows or columns. And then you can say 1 column or 2 columns. And now you get 4 elements with holoviews, which is pretty neat. Especially if you want to put them somewhere specific in your dashboard. I completely agree, Ben. I think holoviews is excellent because it combines the best of the two. Because Matplotlib, the maturity of both libraries, Matplotlib and bokeh, that only means that holoviews has a massive amount of options. So that's one of the things that I find overwhelming learning the tool. It is fantastic. It is incredible. I love it. I'm gonna keep using it. It takes a second to get a sense of like all of the power, like all the power behind that tool. But it is awesome. It's not really related to the exercise, but I was wondering if your thoughts are on using Dash versus Panel. Are they very similar or different, or is one better than the other in certain contexts? So you see, that's a great question, Matthew. I'll be completely honest with you. I have not used Dash. I have used Plotly quite a bit with the R binding, but I have never used it with in Python, let alone for creating dashboards. I've been using Panel because I found it very easy and very highly customizable. Like with a few lines of code, you have a really good looking dashboard put together. And then if you want to get very extensive, then you can go even as low as interacted with JavaScript objects. So I don't have an opinion on it just because I haven't used it before. But I've used Dash and it's fantastic. Sorry, not Dash. Plotly, and it's incredible. I love Plotly. Very good too. All right, so this exercise. So we needed to create a variable called my data1, and we were going to group by the day of week variable. We were going to take the price, and then for the price, we either take the median or the mean. Let's take the mean. Now we're going to take our variable again. And what we're going to do is divide the price column, which is the only column in this data set, by 1,000. Then after that, we're going to reset the index. Then we are going to call, now that we reset the index, so actually, why don't we separate all of these steps? First, we have our group by object with the days of the week on the left and the median value on the right. Oh, sorry, the mean value. In the next one, we divide them all by 1,000 to make them more legible. And then in the next one, we bring out a data frame. So now we have 2 columns and multiple rows. So then for the last one, we have to use my data1 to create my bar. And then for that, we're going to use day of week. And then we can use, here I put 5, but it's good with 3. I'm going to steal the format from this one. Oops, here's the format. I'm going to add a title. I'm going to put my first bar. And then for the last one, color, I'm going to use a brown. And let's get rid of this too. And there we have it. Our first bar. Woohoo. Awesome. All right. So now let's go to the dots that want to be bars. In case we forgot how this one looks like, here it is. I put a copy of it in the folder called dashboards. So what do we have here? So here we have the average price per suburb with 100 plus listings. So when we look at a metropolitan area, we might find the average can be deceiving, depending if we're looking at it by the average of a suburb can be deceiving if we're looking at it by all of the suburbs, but we don't pay attention to the amount of listings that they have. So for example, if we compare the mean value or the median value of suburbs away from the city and suburbs closer to the middle of the city, of the metropolitan area of Melbourne, we might end up taking into account places with 2 listings or 2 houses on sale. So, or 2 houses that got auctioned. So if we do that, we will be, so the average of a house that sold for $1 million and another one that sold for $500,000 in the same suburb will be 750,000. But then for another one that has 150, it would be a completely different story. The average will be, or the median will be more representative of the houses around that zone. And you can make a claim that why wouldn't it be representative if you have 2 in a suburb and that's all you have? Well, it's not a good comparison point for the other ones. So here we pick 150 plus. And what we have, we divided it, or not divided it, we overlay. So remember earlier, I mentioned that in holoviews, you get to concatenate bars and concatenate charts with the plus operator. So that should have given it away. So the other one, the star, allows you to overlay charts on top of one another. And this is exactly what we're doing over here. So we're filtering out. So think about when you look at a chart. In one hand, on the y-axis, you have suburbs. So you have a category. On the x-axis, you have a value. So this could very well be a bar chart, a horizontal bar chart. But in this instance, because we're comparing two things, if we put two bar charts, then the two bar charts would have been right next to each other. While as if we put the dots are right behind the other. Now, what we're interested in is, out of all of these suburbs that have a lot of listings, that have a lot of houses for auctions, how has the price changed from the year 2016 to the year 2007? So we don't need to show a trend if we can see how the average price has changed with a dot. All right, so let's get to it. So the first thing is that, remember, we need the suburbs that have more than 150 values. How do we get that in Python? Or how do we get that in Pandas? So we have our data frame. We have a variable. Variables in a data frame can also be selected as a dictionary in the same way you select the key from a regular Python dictionary. So it will mean the exact same thing. Then Panda has a very handy function called value counts. And value counts tells you, if you press, remember, if you are inside the parentheses of a particular function and you press Shift Tab, then it will tell you exactly what that function does. So it returns a series containing counts of unique rows in a data frame. In this instance, we're only interested in the one for the suburbs. So notice what we have here. So we have quite a ton of suburbs in the metropolitan area of Melbourne. And notice that probably, if I had to take a guess, there's way over 100 here. And what we want is, we don't want all of them. It wouldn't even make sense to see all of them here in the left-hand side of our figure. So we want those with 150 or more. So notice how the cutoff here is 149. So let's do that. How do we do that? So now that we have a variable called subs count for suburbs count, we can say, is there a number greater than 149? And what this is going to give us, if I say here, if I say show me the head of this, notice that this is going to give us a Boolean. So for whatever it is true, we are going to keep. Whatever isn't, we are going to filter out. If you use the tail to look at the bottom 5, you'll see that anything at the bottom, Bacchus, Mars, Wallan, Atwood, all of these suburbs, they only have 1. So they don't qualify. They don't meet the requirements that we're interested in for this particular visualization. So what we do is we pass in this Boolean array into the filtering operation into 2 brackets right next to our Panda series. And that allows us to filter the data set for what we want. Then we take the index and we surround that around the list. And now we have all of the suburbs that we need. Okay, so now that we have what we need, how do we get it? How do we get it to work for us? So the next thing that we're going to do, remember, we get to select variables either with a dot, the name of the variable, and then a particular method. What did the index do? Oh, okay. So let's actually that's a good question. So here we created a series with trues and false. Here we pass the series to that series of trues and false to our I already created the list. I need to run this one again. Okay, sorry. So here we have the trues and false, right? And then what we have here now is the representation of, because we pass because we pass a series with the same length as the one that we're filtering in, whatever is true is going to stay, whatever isn't is not going to stay. Now, when we pass the index, we say, get rid of these values here, the 359, 259, 249, 239. And what it says is, give me only the index of that. So now we get this, and if we pass it around a list constructor, then it returns a plain list. So the index takes out whatever's in the index, and it gives it back to us. So we wanted to get rid of all of those numbers. Not a problem. Okay, so now we have the suburbs that we need. What we need now is pandas has a method called isIn. So we're gonna check, is this suburb inside, oh, sorry, is this list of suburbs inside our major data frame variable or column? If they are, I want you to give me a Boolean array of trues and false. And this is the representation it's gonna give us. I'm gonna say false, this one isn't, this one isn't, this one isn't, this one isn't. Okay, perfect. So now what I wanna do is, we wanna take our data frame. We wanna pass in that mask. So this is called a mask. When you do that kind of operation, when you create a representation of trues and false, you're creating a mask. That mask passed into a set of brackets allows you to filter out some values and leave in others. Once we pass that, we get a group by. And then once we group by, we can do two things. If we take the brackets out, we can only have one element. But if we leave the brackets in, we can pass multiple columns. Now we are creating what is called a multi-level index. So this right now is a lazy object with groups of values. Those groups of values are year and suburb. Now, what we're going to do is we're going to say, okay, so give me that. Let's see, I got a question here. Is it generally true that modules developed later or the modules developed later are better than those developed earlier? For example, holoviews is better than matplotlib is true. Then it is better to know the chronology of the developments and if there's any dependency. So you see, that's a great question. Whether it is better or not, so it depends, because my take is that matplotlib is still, it's still gonna continue to be its core developers and everyone contributing to the library are going to continue to do so. So what that means to me is that not only matplotlib will end up getting better, but then holoviews, which is a wrapper on top of matplotlib, or an API on top of matplotlib, will also get better. Will it get more complex? Maybe. Yeah, my take is that it will certainly get better. All right, so we got our object. To that object that we created here, the subs group of years and suburbs, we're gonna take the price column. We're gonna aggregate that column by the mean and the median. We're gonna divide those two values by 1,000, and then we're going to reset the index. If you're curious as to what that looks like, you can copy it, create a new cell above. You can add new cells with the plus sign up here, or you can use when you are outside of a cell. So when the cell is blue, it means you are outside. When the cell is green around it, it means you are inside of the cell. So if you are outside of the cell, you can press A to add one above, and you can press B to add one below. So if you take that representation out, and you show the head of it, then you see that we have a multi-level index. You can see that these two are completely different than these two that are up here. So when we divide by 1,000, we're dividing every single element in this data frame by 1,000. Not only that, but we are also resetting the index to now have 4 columns as opposed to just 2. So notice now we have 4 columns, and we have the years, and we have the mean and the median and so forth. So now what we're interested in creating 1 year, 2017. We want to take the mean in the x-axis, and we want to put the suburbs in the y-axis. We want the label of this chart to be 2017 because that is what we are filtering for. So now we have a representation that doesn't really look that great. It's not big. it's not sorted, and you can't really understand the years. So again, the defaults, they can be great for a lot of things, but they can also be tricky. So learning how to deal with them and learning how to cope with them is very important. Now, something very, very important to keep in mind when you overlay two things, one on top of the other, is that you don't need to have the exact same set of options for both. You can put the majority of them in one element, the one that's going to be at the bottom, and then you can put only the necessary ones on the second one. So even though most of these functions, most of these options look like a lot, if you think about it, these are almost the exact same ones that we used before. So before we use the color, we use the height, and we use the width. We use the X formatter. We didn't use the X rotation. We use the label 0 to label things out, and we use the title. So new options here that we're seeing is only the X rotation, the toolbar disable, we used it earlier, and the size. So X rotation, legend position, bottom right, and the size are the only 3 new options that we're seeing in this instance. The other ones, we saw them earlier. Now, notice this little detail at the bottom of the visualization. You can actually sort out a visualization from holoviews. Not only that, but if you were interested in actually looking at the data behind a visualization, you can take that visualization and you can add at the very end of it data, and it will show you the data that is showcasing in this visualization. You can also use the attribute table, and it will show you bound, method, element, table, scatter, mean, suburbs, and so forth. And it will show you some sort of representation of the data behind it. In addition, you can also use preprint, and I want to say in pretty print, I want to say it's without this, and it will also show you what it represents, this object. So this object represents a scatter plot where the x-axis represents the mean of some values, and the y-axis represents the suburbs. So that is what preprint and table both show you. All right, excellent. So now in the second one, notice what's happening here. So now in this one, we are calling 2016. We are filtering for 2016. We're taking the mean on the x-axis, the suburb in the y-axis. We are labeling it 2016. And we are taking in the options, we're only specifying 2. Why 2? Because all of the other ones are going to be on the bottom visualization. And what we have is the color that we want those dots to take and the size that we want those dots to take. So you can actually change that size and make it bigger, make it smaller, however you like. So now, notice that it looks exactly the same way as the first time when we created our first one. But what's going to happen is that when we overlay it on top of the previous one, it's going to take all of the default parameters that we put on the previous one. So notice how now we arrived at the visualization that we had before. And remember, we disabled the toolbar. Otherwise, if we wouldn't have disabled the toolbar, we would have been able to come here, for example, to this chart and select everything and go in and zoom in and see specific suburbs in their values. And now the mean is getting a little bit more legible. So I know that Glen Ares is the mean house price is 1.6 million. Remember, this is in the thousands, but here it's not explicit. Here it is because we added a hundred, the K at the bottom, at the back, and then we added the dollar sign at the top. So remember, you should always start, I mentioned earlier, the don'ts is don't betray people with access. In this instance, it doesn't make sense to start from 0 if there are no houses in our data set that have been auctioned for less than this amount. All right, so now we have a neat representation. Now you have a quick exercise. Create a plot that wants to be a bar using the suburbs and the land size variable. So I put less. Also, if you want to save, so remember that we saved this one before. We opened it before we started working backwards on it. So we are going to save it here. Oops. Dashboards. Let's see. Neither Firefox nor Gecko driver, not, well, I am in Binder right now, so I'm not going to worry about either of these two. Although I could. Let's see. We could install them and save them, but we don't necessarily have to. We have to put a Y at the end of that. But we don't have to. All right, so for the last one, since we gotta speed up things a little bit, let's create a plot together. I am using Binder, yeah. I wanted to make sure like this was properly set up for the entire session. So yeah, I'm working through it right now. I have my own in the background just in case this one something were to happen to mine and I had to start over again. But yes, I'm using Binder. I prefer JupyterLab. All right, so let's create a plot that want to be a bar. So we're going to use suburbs and the line size variable. So how do we do that? So we are going to say sub land, and we're going to take our data frame. We're going to group by the suburbs. Then, and remember, if you forgot about the variables we have, you can add a new cell and you can say, and you can call the head. And you can look at all the variables that we have. Maybe this one is still running. Yeah, it's still running. I'm going to stop that one. I don't care about saving it right now. So I got the suburb. I got the land size here. So, and the land size variable. And I am going to take the mean. I put an S here that didn't need to go there. Suburb. There you go. Okay, so now I have all of the suburbs. And one thing that I could have done was to create small subs. And do data frame, suburb is in. We can use the list that we created a second ago, which is called subs mask. We can come down here and say, if this is in here, give us back a data frame. I'm going to create a copy of this. And then I'm going to use the small subs to group by suburb, and then take the land size. Let's see. What do we have here? Okay, we have the small subs.
I think you want to do sub counts, not subs mask, as the is end.
Oh, that is right. It's not the mask, but it's the index one. Let's see. Yes, it's not the mask, but it's the, oh, shoot. You're right. The subs count. I was like, what is happening? Okay. Now we have the right one. If it's in the subs count, yeah, give us one representation. So now we have, let's take the head, but put back our data frame and create a copy of it. There you go. So now we have the small subs. Now we can group by suburb, take the landslide, and create a mean. Now, the very last part is HP that scatter, where we can use tab completion. We can use that last data frame we created. And we can use one thing that we haven't done is reset the index. Index. There you go. So now we can use suburb. And we can use, ideally, the idea of this exercise was to copy all of the code from above and put it down here and just change landslide from the previous one that we used. Land size. But I went the long route and hard coded it all. This wasn't meant to be hard coded. And there we have a representation. Not very, oh, gotta switch this one. Suburb. There you go. Much better. We have some out. Now we can see that we have some outliers here. Well, we finishing out the notebook on my own and watching the recording. Thanks for the great list. No problem, Paul. Take care. All right. So let's go over bands, and then we'll take a short break. And we're almost done with this notebook. So bands, I quote, there's a great book called The Big Book of Dashboards. It is fantastic. As a matter of fact, that's one of the places where I took inspiration for the dashboards of this session. Bands, they consider them two ways. I quote, one is called big ass numbers, and then the other one is called big angry numbers. Of course, we're going to go with the latter, big angry numbers. These are both the definitions from the book, and they are numbers represented to showcase an important statistic in a data set. You have a data set, you have some information that you want to showcase, you might as well put it in a big number, in a place that it makes sense at, and in a way in which it is visually pleasing with the rest of the elements of your book, of your notebook, or of your dashboard. So bands can be created with a pane or something called an indicator. That indicator has a number, and that number might as well be considered a pane. And oh, thank you for putting the link, Perry. Fantastic book. So if you like dashboards, if you make dashboards for not for a living, but in your day-to-day work, and you want to take what you learned from this session and also apply it to other things, I took inspiration from dashboards in that book. So please check it out. Very, very good. I promise they don't pay me to advertise. It's just a really good book. So here we have an indicator from a panel. So this is a pane that is called an indicator. It has a number in it. We can pass in a name that's going to be on top, and then we can pass a value that's going to be at the bottom. So these numbers only take numbers. So to a value, you cannot pass a string. All right, so what are the things that we can do with them? So we can add a default color for it. We can add a font size. The font size, you got to be careful. It's not your particular font size where you put a number and that's it. It's actually a little bit confusing with the rest of the API, which is, it could be a size is a number and some other things are a number, but this one is a string and it is, oops, it's a string and it is as you put the number and then you put the PT. Same for, I want to say, oh, there's another one that we'll see that has the same one, but yes. So the font size, that's how you change it. The title size, you change it in the same fashion as this one, actually. Yes, so 50 PT, 30 PT. What's the purpose of adding an underscore? Where will be the, in the value? Oh, I see. So, sorry, in Python allows you to separate thousands with a underscore, and it understands the same as this. It's just, to me, that's personal preference every now and then. It's just, you cannot do that with like, you cannot put one here, but you can have one every 3 zeros, every 3 numbers to separate the thousands. It's sort of like, it makes it a little bit easier for me to like see the value that is there. So, okay, so here we have another one. We're using more of the options, and we want to start creating our numbers. If you think about it, let's go back to our dashboard at the very top. So we have 5 big numbers up here, and we want to be able to recreate all of those. So let's see how we can get them. All right, so notice that we can change the color. We can change the size of the title. Now is 50, but you can also say like, I don't know, 10. And notice how tiny now the size of the title is. But it doesn't change in any way the font size of the number. So we can have another, we can also format in the same way in which we have been formatting the other numbers. We can format the values as well. So now that we know this, let's create, and notice that we have 5 big bands. Since we have 5 bands, that means that we don't need to repeat all of these options. Or the other way in which we can accomplish the same thing we did earlier with the global options is by creating a function instead of creating a set of global options in a dictionary. And that's what we're going to do. So let's create a function. In Python, you use the define operator, you name it. In parentheses, you put the arguments that your function is going to take. And then here, what I'm doing is, in the very first one, I'm saying colors. And confusingly enough, I'm calling it cols, which is also sometimes used for columns. But what we're doing here is we're setting 4 colors. And if you're interested in knowing where I got those colors from, I really like this set of colors called Nord, and they are all taken from here. So they have very nice black, gray, and frost, and there's one more. So earlier we mentioned, I mentioned that there's 3 kinds of colors. There's divergent, there's categorical, and there is sequential. So these ones are considered sequential. This one is considered categorical, where each category is going to have a different one. Because we have 4 different ones, we're using 5 different numbers. We're using these 5 different colors, which is called the Aurora. And this is not recommended in a sense that if you want to make it, not recommended because it's bad, but if you want to make your charts very visually inclusive, then you want to make sure you don't add too much red and green, as those are the more common color blindness cases that you see people. I believe is 1 in 10 men is colorblind or so. So we have a set of colors, and it's much more higher in men than it is in women. So we have these 5 colors, and we have a value of 1 as the default. We're going to take a value, as we saw up here, for example, the number 1000, and then we're going to take a title. We're going to pass all of these parameters to our function, and it's going to return a band. So let's test it. So we have a title called testing. We have a value of 500, and we're taking the color. Oops, I have to run my formula. And then we're going to test it with a color of 0, or the one in this value right here at this index. So 0, 1, 2, 3, and 4 in the same order as you saw the Aurora. All right, so what we're going to do is we're going to take the minimum price, which is the very first band number we have. We're going to take the min of the price column divided by 1,000 and use the color number, the last color, the number, the one at index 4, but which is the 5th number. Remember, Python goes from 0 to, starts counting from 0. We're going to do the same with the 25th percentile. We're going to take the quantile, which is the interquantile or the interquartile of a quantile is a percentage of a distribution. In this instance, we're taking the 25th from the price column in our data frame. We're taking the median, which we don't need to pass anything to, 75th, and then the max. And then we are displaying all of our bands. Perfect. So what we're going to do is we're going to skip this exercise because we have more bands coming up in the next notebook. We're going to take a 10-minute break. And yeah, don't forget to run, if you're in Binder, don't forget to run your any particular cell in the next 5 to 7 minutes so that it doesn't come back. Oh, nice. Okay, awesome. So it is, do we have 20 minutes left in the tutorial? No, we don't. We have about an hour and a half left, Perry?
We have about 21 minutes left, I believe. So
Wait, in the tutorial?
I believe so. Let's see.
Forgive my surprise. I thought it was.
Okay, I'll double check, but I think it's 21 minutes left. So to
Okay.
2:30 Pacific, which would be 3:30 Eastern, or 5:30, excuse me, Eastern. But I'll double check.
Okay, awesome. Thank you.
Okay, sure.
Yep. All right, so 7 minutes, everyone. Let's be back here at, it should be for you 6 p.m. So 6:30, no, 6:30, sorry, 6:15.
So 7 minutes, okay, great.
Yeah.
Thanks.
All right, everyone. So welcome back. So let's continue where we left off. So we were about to go towards the title of our dashboard. So remember, we have one column composed of 4 rows. One of those rows is by the title, the other one is by the 4 bar charts, and then the other one is composed of the map and the layout chart that we created. So now earlier we used an indicator with a number. Now we have a pane with a markdown cell. And remember that we can use a row, and then a row also takes strings as markdown letters. So in the same fashion as the number has a styling and font colors and so forth, so does the markdown one. In the style, we can control the color, in which case we have to pass in a dictionary. So that's a little bit different than the previous one. We can control the sizing mode, whether it rearranges itself with the resizing of a window, and then we can control the margin. How closely do we want it to the edge, to the top, or to the bottom of that row where we're gonna fit the title in? So here we're gonna we can see another one. We are changing here the color to a different one, to one of the ones in Nord. Here we are creating another one where we are where we assign the stretch width, and we set to the margin. So the margin is top, left, right, bottom. So you pass in, if you want to change the margin, how it gets resized, how it gets set up, you have to pass in a 4-way tuple, a 4-number tuple. Now here we are passing the color again, and we are passing the width of 500. So now we have the header. Notice how it's looking way more like the one that we had before. Now, panes also take pictures. So for example, here we have a PNG. And then what you need to be careful with is that if you don't resize them, you will end up with a gigantic picture. So here we're gonna set, we want a height of 50, we wanna fix the size, and then we wanna center it in this pane. And now we have a tiny house image because this is the analysis that we're doing. Then in the next one, we have the same. We have something that says, since we have auctions, we have here a tiny object or a tiny image that says sold. And now we can create a row. That row can have our 2 of our images, and those 2 images will be displayed right next to each other. You can also add something called from panel called a spacer. The spacer will add a space as much as you want in between 2 objects. So for example, here, now you can see that there's a bit more space in between the 2. And if you add a one with 30, then you see them even further away. So now what we're going to do is we're going to create that row that's going to serve as our title before we get to reconstruct the dashboard. So now we have the first piece. So we have 25% of the dashboard. Notice how here we have what's going to be at the top of it. Now we're going to skip this exercise because we're running out of time, but I'm going to leave that one to you. Now for the last one, for the last piece of the puzzle, the map. So our question is it more expensive to live in suburbs that are closer to the central business district? So we can reshape the question that we started off with. Is it closer to live near the city, or is it more expensive to live near the city? So the first thing that we're going to do is remember that our substats, the geodata frame that we created, that geodata frame, we're going to add one more column. By adding that one more column, we can add it with the same way in which you select a key from a dictionary. We're going to divide the median by 1,000, and we're going to add it to our data frame. Now, we were using holoviews, which is HV, and now we're going to use GV for Geoviews. In Geoviews, we have, remember that in our that geodata frame, we have polygons. So we're going to visualize a polygon. We're going to pass in our stats. Notice that it is not taking a key dimensions because the key dimensions of a geodata frame go immediately to the shape of the polygons. So what we do need to pass is what are we going to overlay in that additional image? 2 things. We want the suburbs and we want the median in thousands. We want to add a label to represent the title of our chart. Then we want to create a width and a height for that map. And and we want to be able to hover over the states. So now it's generating that image for us. And notice how this is not technically good. This is not technically a good image yet. We can zoom in and try to see it, but it's still not well represented. And the reason is because it has two cities, Hillside and Belleville, that are way, way away from the metropolitan area. They don't even seem to be in the metropolitan area of Melbourne. So what we're going to do is we're going to create two booleans, and we're going to pass them to our data frame. We're saying select everything that is not these two cities. And now we're going to get a different representation of our map. Also, if it gets a little slow, what you can do is, let's see, cell, kernel, view, edit. Where is the clear all the cells? Okay, we're going to clear all of the cells, and we're going to run this one again. And then now that we're about to have a different representation of the one we had before, we notice now how we deleted, or we took out, we filtered out the two cities or suburbs that were very far away. So now we have a better representation of the city of Melbourne. Now, so what we see here is that something quite interesting. Towards the middle of the city, we see that it's quite expensive. It's about 1.4 million to live near the center of the city. But then to the outside, it's about $500,000. So right now, the gradients of the choropleth map, this is called a choropleth map, they are not in a way in which is intuitive for us. So if we were to put the most expensive one in the darker tone, as opposed to the lighter one, it will make more sense as to what is the most expensive and what isn't. So now, let's do that. Let's change with, remember, most of the options that we're seeing now, they are somewhat repeated. What we want to do is we want to get rid of the x-axis. We also want to get rid of the x-axis and add a color bar. That color bar represents the shades. Then we want to color the cities, the suburbs, by the median in thousands. We want to be able to hover over those. So notice how now the most expensive suburbs, they are towards the middle of the city or closer to the central business district, as opposed to in the outskirts of the city or the metropolitan area. So what do we want to do now? What's the last step for this? Well, we might want to change the, we probably want to change the color of the map. And then holoviews provides us with something called the tiles. The tiles have different maps that we can overlay underneath the two layers of representations that we have. So let's do that. Let's add one tile with what is called the OSM in the, and I forgot the exact representation of it, but you can see all of the maps in working with bokeh in this link that I put over here. Then. So now we can see this is the state of Victoria, and then this is the metropolitan area of Melbourne. What we did here as well, notice, because we want a static map, we got rid of the hover functionality. And you can see it over here where we put toolbar, disable. So now that we have this, now we are in the last step of the dashboard. So what we got here is the very same row that we created earlier, the one that represents the title of our dashboard. In the second one, we have all 4 bars that we created at the very beginning of the session. In the third one, we have, notice how we are using a fixed size because we want to create a dashboard that doesn't move, something that we can put as download as an HTML file and give it to somebody else, or print it, save it as a PDF file. And here we have the width. We are setting the width. of that row, that object. So now we have the second one. We have 50% of the dashboard done. Now we have all of the bands, and we have them in a fixed size again, because we don't want this to move. We don't want this to be resized with the change of the layout of our page. And then in the last one, notice how we are overlaying the map underneath our Melbourne map, and we are relabeling the title of that chart. We are fixing the size of it, and we are aligning everything to the center. We are not going to display that one, but we are going to display it in our dashboard. So now we create our dashboard. We're going to add all of those, 25% the title, 25% the bars, 25% the bands, the numbers, the big numbers, and 25% the map and the layout that we created with the scatter plot. So now we can add the show, that show to our dashboard. And that's going to send us to a server. And we might not be able to see this server here. So what we will do is, since I'm in bokeh and not in bokeh in Binder. So I'm going to show the dashboard in the notebook. So notice how we are pretty much almost done with the dashboard. The last piece of the puzzle is the inside of every single chart, or the aesthetics, the background color, the axis colors, and something that will make it look exactly like the background behind it. So how do we do that? We're going to skip that exercise as well, but I hope please come back to it and fill it up. So bokeh has something called theme. And then that theme takes a JSON file. A JSON file or a JSON object is sort of the same thing as a pandas, not as a pandas, as a Python dictionary. It's a dictionary of keyword elements. So what we're saying here is we loaded the theme object from bokeh. We're passing in a JSON object, and it says, I have attributes here. In those attributes, you have a figure. For those figures, you can fill in the color with a particular color. The border, you can fill it in as well. The outline as well. Then you have a grid. How do you want those lines to be? How do you want the dashes to be? 6 by 4. How do you want this? How do you want the space to be? Or what do you want the space to be? .3. Then the axis, the color, the text, the line, the ticks, the axis line color, the label, and then you can also color the title of your charts. So all of those are attributes of a particular chart. We can load all of this up. And remember, you can come back here and change the hex colors to whatever you like. And then we pass in to the global options. We pass in the theme. And then we can show again our dashboard. And now, by the time you get to the very end, by the time you get to this one, you probably want to save it. So now we have the exact same one that we started with. So this dashboard, we can print it, we can save it as an HTML file, we can save it as a PNG file, and we can share it with friends and colleagues and whatnot. So the last piece of the puzzle, if you want to save a dashboard, you use the method .save, and then you add the extension at the very end that you want to use, in this case, HTML. So that's it for this notebook. Perry, let me know. All the screens of Teddy will be here continuing the webinar for free. Okay, perfect. So I'll go ahead and move on to the next one, and then yeah, let me know. Let me know when to stop. I think we got time to cover the next one. So let's go to the next notebook, which is the interactive notebook. So now we learned how to create, how to deconstruct and construct back a interactive dashboard. So now, a static dashboard. So now what we're going to do is to create an interactive one. So we're going to have, again, the dashboard. We're going to have the scenario, the use cases, the data, and then we're going to go to the top-down approach. So if you uncomment this cell, you can check out the representation of our new dashboard. So what this dashboard does is that it has, and it is still loading. So we have quite a few things here. And I also, and this one is an HTML version of it. So this one will probably won't update as you move it, but it might. So as you change things about it, it should start giving you new output. And what we have here is the bands. Again, we have two widgets that control the entire dashboard. And then we have a couple of other representations. So let's go about it. Let's go into more detail of it. So the scenario is that whether we're planning a vacation or we are planning to do some sort of marketing campaigns, and we want to know whether there's more people more tourists going to a particular area. Sadly, not right now with COVID, especially here in Australia. We want to have an idea of how populated are specific areas or how popular they are in terms of reviews, people going to or staying in particular locations if we want to go somewhere. For this case, we want to go to Sydney, where I currently live at. We want to go to Sydney and we want to learn a little bit more about Airbnb because we don't want to spend money in a hotel. So what do we have? So we have, this will be useful for a tourism agent, for a data analyst, such as government, or real estate, restaurants wanting to cater to tourists, real estate agents, and many more. The dataset. So the dataset comes from a place called Inside Airbnb. And there's more information in the README file available in the website. But what it has is, in a nutshell, Inside Airbnb scrapes all of the data from Airbnb periodically, which means that anything that you will see on the layout of Airbnb when you go and try to book something, you will find the data set in their sources. And the one we're using is particularly for April, for Sydney, for the city of Sydney, for the metropolitan area of Sydney in the state of New South Wales, up to April 2020, or that was the last time that this one was scraped. And there's way more information available inside Airbnb, and you can certainly download the datasets from there. So there's a couple of new variables in addition to the ones that you would expect to see, and that is mean price per stay. Airbnb displays the price per night, not the price per stay. The price per stay, some hosts have, or every host has the option to put a minimum amount of nights for which they will rent their place, their location. And that might not be one night. So the mean price per stay is the price times the minimum amount of nights plus the cleaning fee. Then the 2-week price is sort of the same, but times 14. Take out the minimum price and think about 14 days. All right, so let's load our dataset. And notice that we have 32,339 listings and 93 variables. We are going to showcase Thank you very much, Ben, for the nice comment. Thank you. Awesome. All right. So we're gonna look at the info. So we have 0 missing variables. I took the liberty of cleaning this beforehand and also adding several new variables and taking out some that weren't useful. And then we also have, as in the previous one, we have a file with the neighborhood locations. And remember, when we get a GeoJSON file, what we have is usually the multi-polygon or a polygon, a square, where that contains an area. And that area might be the location of a suburb or the location of a town or the location of a city inside geographical location. So in this one, we have a multi-polygon. And we have 0 missing variables. Actually, sorry, we have one missing. We have the neighborhood groups, which doesn't represent anything. We have it missing, but we only care about the neighborhood and we only care about the geometry. All right, so let's deconstruct this. So the first thing we're going to talk about are the widgets. And the widgets So the widgets is the very first thing that we see in our interactive dashboard. What allows us to go and essentially interact with the charts that are in our display. So how do we create widgets? So let's first think about the very first chart that we saw. The very first chart that we saw, the very first widget that we saw, had a property type. It had an apartment. It had houses. It had condominiums. So what if we can create a widget like that, and before we even add it to any other chart? So let's do just that. So we're going to take the unique values of the property type column of our data frame. And let's actually visualize our data frame up here. And I'm going to put two rows. And we're going to navigate to the property type. And here it is. So here's the property type. So we have apartments, we have houses, but we not just have that. We have a ton of other properties. So we have house, condominium, townhome, loft, cottage, village, guest house, and so forth. So the way we create a widget, the thing that will allow us to interact with the charts inside our dashboard is with panel widgets select. Select gives us a select box or a drop box. And what we need to give it is a default value. With that default value is going to also take, after that default value is also going to take a list of options. So I have a default value, but where am I selecting from? And also, you might want to give that widget a name. So we're going to give it a name, the name of property type. So let's see what that does. So that gives us a property type. A property type has a list of columns that we're going to be using later on. So notice how we have condominium, cottage, village, others, and so forth. So it doesn't have anything to interact with, but it will give us that, that ID or that capability here in a second, once we combine it with a particular chart. So now let's look at the scores, the reviews. So something that anyone is interested in. So there's a couple of things that interest me in particular. If I am traveling somewhere else, especially if I'm looking at a place to stay at, one is, okay, how much am I going to be paying? Two, what are the reviews of this place? So, I try to be as unbiased as I can when looking at reviews, but it is nice to see that where you're going to stay at has a high number of reviews and a high number of reviews that are good. So what we're going to do is we're going to create something similar to what is called Net Promoter Score. Net Promoter Score is in terminology of marketing where it is considered more 9 and 8 in a review is considered the promoters. The people that rate something 9 and 10, sorry, are considered the promoters. The people that rate the experience or the product or whatever, 7 to 8, they are considered passive. And then the ones from 6 to 0, those are sort of like no bueno, nothing, not necessarily bad, but that is the way it sort of is considered. They don't promote, they don't bring in more value, or they need to be moved towards the upper end of the spectrum. So here we have the review scores in terms of 100. And what we're going to do is we're going to create a new column. That column, we're going to call it none. And why are we calling it none? Because we're going to have listings without any single review. So what we want to say is like, fill in this entire column with just nones. Now, what I'm going to do is I'm going to create a function that says, take each one of the reviews. If that review is greater than 90, we're going to say this is excellent. If that review is not greater than 90, but it is greater than or equal to 70, we're going to say it's okay. If not, just say no bueno. And that's how we are going to do it. We're going to create a mask because we cannot evaluate reviews that have 0 reviews. They're just going to be 0, and we're going to be biasing towards the lower end of the spectrum, the new variable that we have. So what we're going to do is we're going to pass in that mask to our data frame locator. We're going to select the new variable called NPS, and we're going to say, we're going to do the exact same thing. We're going to put the exact same thing on the other side, and we're going to use pandas apply function. Pandas apply function gets applied to every single element inside a row, in a column, every single row inside a column. So it's going to say, for the first value, it's going to take get NPS, and it's going to say, if this value is 90 or whatnot, give me an excellent for it. So if I say number of reviews, and I take the head of that, sorry, not number of reviews, it's supposed to be review score rating. That's the one that we're using. So it's going to say, if there's a 93 here, a 90, 100, 100, whatever, give all of these ones excellent. If there is something, for example, here I have a 0, but if there were no reviews there, then it's not going to allow me to classify those. But if there is a 60, then it's going to put that one as no bueno. And it's going, that function is going to be applied to every single row. So notice how now we have none, 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 and then this one is called no bueno. So now we're going to, let's evaluate how many values do we get. So we got, out of the 33,000 that we have almost 19,000 excellent, 8,000 none, close to 4,000 okay, and then about 1,500 no bueno. That's a good distribution of values. What we're going to do is we're going to take the unique values of NPS. We're going to remove the non one. Once we remove the non one, now we have a new list of values that we can pass on to another widget. So if we go back to our dashboard, we have 2 widgets. One is called Net Promoters, and another one is called Property Type. And we want those 2 to control our dashboard. We want to be able to see what kind of property am I looking at, what is the value of it, what are the reviews, and then what kind of promoters, what kind of review, like what are the reviews? Are they excellent? Are they okay? Or are they none? So let's create our second widget. So now we have the other one, the Net Promoters, and it has 3 values: excellent, no bueno, and okay. So since we are a little bit behind time, we're going to skip this exercise, but we're going to try to complete some of the other ones for sure. So here we have, now you've noticed that we've used the select twice, and that's the one we're going to use. We're going to use another one called interact, but there's quite a ton of widgets that are very, very powerful and that can help you a ton with interactivity in your dashboards. So that's it. You can check them out in the panel widgets page. Let's move on to the next map. So by now you've noticed that when we try to summarize a particular statistic, we take the data set, we summarize it, we condense it, we create a group, we aggregate in some sense, and then we derive the statistics and we add it to something. In this instance, we're going to do the exact same thing. We're going to create a data frame. And we're going to say, you know what, just give me the apartments. Let's just check out the apartments. Then after we notice that the apartments make up about 2/3 of the data set. So then we're going to group by the neighborhoods cleans. So the ones that have the matching neighborhoods with the geo data frame that we uploaded at the very beginning. So we're going to say, give me the mean price per stay. And then we're going to get the median value. Remember, the minimum price per stay is the price times the minimum amount of days that a host listed under put out on their listing, plus the cleaning fee. We reset the index, and we have a nice value, a nice representation. So now that notice that we have a summarized data frame, and we have a geo data frame here. So what we're going to do is we're going to merge our data frame. So this is, if you've used SQL before, this is in the same way. This is sort of like a join as well. We're using a left on, join, and we are combining the neighborhoods, and we are adding the geometry to this data frame so that we can have the polygons and visualize them. All right, so now we have the minimum price per stay, the average, and then we have the polygons. Notice that this is still a data frame, and we need a geodata frame to be able to map the coordinates to a map. So we're going to convert that into a geodata frame, and now we have one. And then we're going to pass it in the same way in which we saw the last visualization in our previous notebook. We're going to create a visualization of polygons with a map that we have, mapping the vertical dimensions, the suburb, in the vertical dimensions or the value dimensions, the suburb, and the minimum price per stay. We're going to use the same options that we saw before. We're going to use the color map. We're going to use the height and the width. We're going to color by the price so that this changes. And then we're going to give it 20 steps at the color levels. So we're going to add a tile so that we can visualize our map better. And now let's look at Sydney. So here we have Sydney. We can see the prices. Must be right. So awesome. So now that we have this, okay, how do we add interactivity to this? Because this is the whole point of this notebook. How do we make charts? How do we make a dashboard where every component is linked to one another? All right, so the way we do this is earlier we created a widget, and that widget was called p-type. P-type stands for property type. We created that widget so that we can interact, so we can have a selector of locations of property types. So now panel has what is called a decorator called depends. A decorator is a function that gets wrapped on top of another function, and it takes as input that function. So what we're doing here is we're saying a panel created with this function will depend on this parameter that we get to change. So what's happening? Every single row that we created here, we are going to condense that in a function. We're going to put that in a function. We're going to make that function return this object. And we don't even need to tell it to return the widget that we created earlier, because that was in our very first few cells. And we're going to see this over and over, the same pattern. So notice all of the cells that we just ran, we just put them in here. And now we are returning that representation. So now that we have that function, what we do is we call the function, no arguments. So remember, the only argument it takes is that property type. And then the keyword arguments, they're there if you want to change something later on. So now we can add a row, and we can add the widget and the map. Notice that now we have the widget on the left and the map on the right. And not only that, we get to change this to another representation, and notice how now the background starts changing. So every time, this is important to keep in mind, especially if you have large data sets. Every time you make a change, your function computes a new value. So Python starts doing a computation, and then it sends new values towards you. All right, so now we have this representation of a map. What we're going to do is show you the second one. So imagine that we have that now we want to visualize the minimum, the mean, the median, the max, and the count. And we want to create a group object. So notice how we have now the neighborhood, and then the scripted statistics about the price. So we can create the geodata frame in the same way in which we created the previous one, merge one data frame with a geodata frame, convert it back into a geodata frame. We get the polygons again. Notice the pattern. Now we can wrap all of this in a function. When we wrap this in a function, we can also use, instead of the previous widget that we use a widget selector. Now we're using a widget interact. And what the second map does, or what the second get map does, is then it gives us the exact same representation. But this time, the default for interact is a column. So notice how it took the keyword argument and it put it here. And it took a list of values that represent the columns in our data frame. And it's going to allow us to change all of those interactively. Because this is binder and we only have 4 gigs of memory, it takes a little bit to compute. It's not the fastest, of course, but it gets the job done. So we can see here that this is the most expensive one in terms of max, Hornsby, and then near the inner west of Sydney. I don't know if any of you have ever been here to Sydney, but the center of the city is right here where the Opera House is at, sort of. This is considered Sydney suburb. And then this is the North Shore. This is the eastern suburbs and so forth. Very beautiful place. So, okay, so we have another exercise here, but I'm gonna leave it to you. And what we're gonna do is we are going to do the next one. So interact creates, sorry, I missed a comment here. So interact creates a drop-down widget automatically, so you don't need a decorator to link the widget to the map. That's correct. That's correct. Now, this is the cool thing about interact that is different than selector. The selector will give you this selection, this select box automatically. Interact though will give you, interact will give you, if you pass it a number, it will give you a range. And to that number, so for example, if instead of putting call here, I would have put like some sort of value like 4, then it would have tried to make something up with that 4. Well, I guess not in this instance. We define as a tuple string. Yeah, it wouldn't take it in this instance because because this is what I have here. But if I would have put other variable, then let's say percentile or something like that. I want to say it won't take it. Now, if it was a numerical value, what it would do is that it would try to give you that representation. If this was a number, and if you don't give it a range, then it would just give you a random range. If you want to give it a range, you can give it like 1 to 20, 1 to 10. But remember, call means it will have to be a number for us to be able to do that. But yes, the difference is exactly as you mentioned. It's like it doesn't have to, we don't have to pass it as a decorator. And it will still give us the representation that we want. Okay, let's go to the next one. So a table in holoviews is essentially represented in pretty much the same way as a table in pandas, but with the addition that we get to make it interactive. A table in pandas might be changing in size, might be changing in values, might be changing in a lot of things, while in table in holoviews might preserve, or we can make it preserve the values that we wanted to preserve. So say, for example, we have all of these reviews. Reviews are very important, especially in Airbnb, in a place to stay, in a hotel, in anywhere. Reviews are important. So check-in, cleanliness, accuracy, location, communication, and scores values. So what we want to do is we want to create a better column or a better name for that representation in our chart, in our table. So we're going to say for the all column, this one here, checking, change it to the new one, checking, create a mapping from the old one to the new one for the old and the new one in this list of here and this list of here. Zip, what zip does is that it matches this one with this one, the first one with the first one, the second one with the second one, the third one with the third one, and so forth. Okay, so let's create that representation. Notice the mapping. And then what we're going to do is we're going to say, okay, so let's create a mask. where the property is the apartment again. So we did this a little bit ago. Then we're going to check that the reviews, the number of reviews are greater than 0. We're going to pass in these two Boolean values with an AND operator. So it's, remember, if this one is an apartment and it also has greater than 0 reviews, keep them. If not, take them out of the data frame. We're going to rename these ones. So we use the data has some columns. We're going to rename all of those columns with this mapping, the mapping that we have up here. That mapping goes to the axis number 1, and we're going to keep it in place. In place means whenever you do a change to this, keep it there. All right, so now to one of the last pieces of the puzzle, we are going to take the mean of all of these new variables. We're going to create a data frame with it. We're going to change the name of the series, and then we're going to reset the index. And if you're curious to see what is happening, we can take it to the next cell and say, show me the group. And I'm going to comment out the reset index. So now index and then the values. And if we take the reset index one, then we have both columns and then the representation of a data frame. So now we're going to say, change those two values. Change the column names for index to reviews and for average score to values. And now we have a table. So this is a holoviews representation of a table. And what we want to do is that we want to link this to one of our constructors, to one of our parameters, so that when we change something, we get to see the average review that that particular locations on the aggregate got for this particular type of review. Now, notice something very cool about the tables as well. You can make them, you can sort them. You can sort them up and down, however you like, or by alphabetical order. So, all right, so let's now do the same thing. We created a table step by step, step by step, step by step. Now we put all of that into a function where we say, calculate this given a particular property type, create a mask, always take this one, always take reviews that are greater than 0. So technically we could have taken this step outside of this function, but oh well. Filter out the ones that we don't need. Rename the columns of the dataset. Take the mean of all of these type of reviews over here: location, communication, check-in, accuracy, values, and cleanliness. Once you do that, change the names of the columns. Give me a table. All right. So now that we have that one, remember we can take the function and apply one argument only, and it will provide us with not a slider, but the apartment average alone. Now, if we want to see the slider, then we have to put it either in a column or in a row. So now that we have condominium, so we can change. Let me put it here so that you can see the apartment and the, let's see if, I know it's difficult to see and to see them change because it's happening so fast. And the, oh, there you go. So you might, now you should be able to see. So there you go. So everything changes dynamically. And now we're going to create the whiskers, the box and whiskers. What do the box and whiskers do? The box and whiskers, they create distribution, or they give you this representation of the distribution of a variable. What kind of representation are we talking about? We're talking about the maximum, the interquartile, so the 75th percentile, the 25th percentile, and the median value of a category within a variable or an entire variable. At the top end and at the bottom end, we have the whiskers, and those are the max and the minimum. Anything above that, anything below that is considered an outlier. usually the default for a box and whisker plot is to have an outlier is above 97.5%, below something like that on the opposite end of the spectrum. So anything 97% above, 97% below, it's going to be considered an outlier. So is there a question here? Oh, no, yeah. Okay, cool. So now let's do the same. Now, by now, you should be familiar with the process. You have something that you want to aggregate by, and then you create a representation. You filter out by that. So here we're going to say, we're going to use now the NPS score. We're going to select the excellent one. Now we're going to say we have a budget. Say we have a budget. And what did I do here? And we want to stay for 2 weeks in Sydney, but we don't want to spend more than $2,000. So we're going to create two booleans, two masks, and we're going to pass in those two masks in our data frame. We're going to say locate where the index equals true for NPS mask, and the budget mask, and select these two columns, 2 weeks price and the property type. Create a copy of this data frame. And now, since the label is quite big for this visualization, we're gonna add it to a variable at the top. And then we're gonna use our box and whisker. We're gonna pass in the data, and we're gonna say property type for the x-axis and 2 weeks price for the y-axis. So notice that we now have a similar representation to the first one that we saw in our in our dashboard. But again, the defaults are not always the best, or are not always the best to represent your chart. So you have to tweak them to get to your desired outcome. So the options that we've been using, they're going to seem, some of them, or quite a lot of them, are going to seem familiar, especially the width, the height, the rotation, we already used it, the background color, the label to erase this property type, and the y-axis label. And then the new ones here are the outliers color, the box line color, the box line fill, and the whisker color. Okay, so let's create this new representation. So notice the top of the whisker and the bottom part, they are the min and the max. The edge of the box is the 25th percentile. The middle part is the median. The top part of the box is the max. Or sorry, not the max, the 75th percentile. No problem at all, Luri. Thank you very much for coming. Awesome. Fantastic. Have a great rest of your day. All right, so now that we have the chart that we need, let's put it all together, and let's make a function that will wrap all of that information inside and then change given a parameter. So that parameter, of course, is our net promoter score. We're going to have it as the key argument here. And then we're going to have the exact same functionalities that we just did up here. We're going to wrap it around the function. And we're going to display it. So now notice that we used a column, but we could have as well used a row, and it would have been the same outcome. So we are in OK. We're going to change to excellent, and notice how the layout changes as we do that. Awesome. All right, so now we have quite a few widgets. So we have done the map, both widgets, the box and whisker. We have also done the table, and now we're missing just two more things. We're missing the plot bar, and we are missing, let's see, we have distribution for the clean column. So I'm gonna continue here because I know we have about few minutes left. So, all right. So in the plots and bars, the same as that we did in the previous section, what we're gonna make is another overlay. But this time, this overlay for us is gonna be a little bit different. We're gonna use superhost and not superhost. So in Airbnb, you have it's sort of the status, or not the status, sort of the credibility of a host. If I had to put it into words, so, yeah, you are considered a super host if you give excellent treatment, if you you know, your place is spotless, you are friendly, you have a great venue, and blah blah blah. So let's use that and let's see if there's a difference in the prices, or in the, sorry, not in the prices, but in the number of reviews that a super host receives versus the number of reviews that a regular host receives. So what we're going to do is we're going to create another mask. This should seem familiar by now. Create mask, aggregate, get what you want, display. So we're going to use the masks, all three masks. We already created a property mask from above, so we're not going to recreate it again. We have the reviews mask here, and then we have the NPS mask as well for excellent. Then we're going to group by the neighborhood, cleans, and whether the host is a super host or not. We're going to use the number of reviews. We're going to take the mean, and we're going to reset the index. So notice how now we have the neighborhood, whether it's super host or not, F for false, true for true, of course. And now we have the average number of reviews that our host receives. So let's create two data sets, one for the trues, the superhost, and one for the regular host. And now we get to pass into the same scatter that we created earlier. So remember, even though the functions, the options look like a lot, they only need to be applied once, especially when you are overlaying something on top of one another. An image is a representation. An image is an encoding. You have data. You have coordinates. You have an X and a Y axis. You have a representation of that data on top of that X and Y axis. So what does that mean? If I have time series data, I am most likely using as a representation a line chart. So you have layers and layers and layers. And in this scatter plot, we have the same. We have two axes, one in which a category will be represented, the other one in which a value will be represented. The dots are the encoding that will represent the values in our data set. In this instance, the number of reviews and the neighborhoods. All right, so let's add a legend. But notice that the legend will not show up right now because there's no need for it. There's no need for it because there's only one representation. There's only one data point. So in this next one, we're going to create another one with the regular host. But notice that we will not care about the about all of those options that we use beforehand because they are already they will already be there by the time we overlay the two objects with each other. So notice how the plot comes up. Very messy. No order. You cannot understand the x-axis for sure, even if you continue to zoom in and zoom in and zoom in. So now, let's put them both right next to each other and notice what happens. So there's a couple of things that might pop up immediately, and it's like, okay, so regular hosts are probably regular hosts because they don't receive that many reviews. Well, not quite, or not technically. It could be the majority of the people that are in the category of regular hosts, they are regular hosts because they are fairly new. They're regular hosts because they haven't been in the business for quite a while. So they might, or there might just not be that many of them in comparison to superhosts. Maybe the standard for becoming a superhost is actually, it's not that high. Maybe it is. I don't know. I'm speculating from the visual. It makes me question the data. It makes me think about the data. It makes me think about what I'm seeing. Now, same pattern. We create a function that contains every single line that we just wrote. What is the dots one, dots two? And we represent the only changing parameter by the two things that we want. Now, this is the first time we do this. This is the first time we add more than one parameter to a particular function, to a particular visualization. This time, we're using both the net promoter. So we're going to say we want a column with both widgets and the dots. And notice how now we have, now the reason why you don't see the white one is because, or sorry, not the white one, the colors at the bottom, is because I forgot to change this white to the gray. So if you come up here and you take the gray and you change it in the function at the bottom, and then you run it again, you will see the gray dots. They are there. So now we get to change the apartment to a house. Notice that just changed, and then we can change from excellent to okay. And then let's see what we have. Notice how there's a ton of suburbs that actually don't have any reviews whatsoever that are in the okay. So notice how the story just changed. Before, we could only see the amount of reviews. Now we actually get to see whether the reviews were excellent or not. So this is the power of interactivity. It allows you to ask questions and answer them in multiple ways or in one same spot. We have the amount of reviews at the bottom, and we're like, all right, but are they good? Are they bad? Or just a large number of reviews? Also, but what kind of property are we talking about? Are we talking about apartments? Are we talking about houses? Are we talking about condominiums or townhouses? What are we exactly looking at? Here we're looking at the lofts, for example. And it's going to take a second to load. And now we can see that, yeah, lofts actually in quite a few places have very good reviews. And it's not that they have 0 reviews. They might have very, very few, but this is also on average. So another piece of information that we're missing is for how long has this host been a host in Airbnb? That would also be something very important. All right, so we have 2 more things to be done with this one, and those are the bands. Because we just created bands, we have a function that takes in the property type. We create a mask for the property type. We filter out the data. We create a title for that band, and then we create a column for which we pass the main title and then the number, the panel number or the indicator number. All of the options that we have used have been added, the default color, the font size, the title, the format, and so forth. And now we get to test it in, notice that this is white. So we're not going to be able to, so let's change it here for the sake of argument for black and black in the default color. And now we have it. So here is the loft. Here are the listings. We can change it to an apartment. And notice how that just changed to, there are about, so this is the raw count. This is the raw count of values. And we have PN mask, and we're summing that mask. So technically, we don't even need the data here. We could even take it out and still just sum the mask. All right, so lastly, what we're gonna do is we're gonna multiply this by 3, essentially. And we're gonna add, because we have 3 numbers. So we have the global options, because now we have more than one. We have the mask. We create a copy of the data frame. We sum up the listings. We group by the host is superhost or not, and then we count them. Then we take the average price in the entire data set. We create a title that contains the property type. And then we create 3 representations, 3 bands or big numbers. We put them in a column where we have the title and a row with all 3 numbers. We align them at the start, both of them. Oops, sorry. And now we have the representation that we want. I didn't put one here, but we can call the bands in a row, for example. We can use PN for panel, the row, add the widget, and then add our function of bands. And notice that because I have a white here, I will have to change it to black to be able to see it. So let's actually change it to black. There you go. And there are our 3 bands. And all of them will get updated as we make the calls with the property tab widget. All right. So last thing.
I'm gonna take my headphones out. Can everybody hear me fine? Okay, cool. I think
Yes.
it was because the battery of my headphones was running a bit low. But yeah, so now we have the representation that we want. We have a widget that is changing dynamically the numbers that we want to change. And if you notice, let's scroll back to the top. When we change the property here to condominium, whatever, remember that this is an HTML file, so it's not going to update this version. So what we want is that all these 3 values change and show something about the data itself. All right, so let's get down to the very last view. And here with bands. So now we put it all together. Now we have everything we need. We have the big numbers, we have the box and whisker, we have the table, we have the dots plot, and then we have the map. So now we get to put it all together. We have a pane with a markdown string where we're going to put our title. We have the color, the width, the height. We say stretch the width, but not the height. Also, before I forget, oh yeah, I did put it here. I gotta make them white again. All right, here we have an image. And then for this image, we have a little GIF. So you can also do that with panel. You can put animated images. And then now we have our final title. So notice that you don't see the words here because it is in white. But now that I have a darker background, then it is much easier to see. If you're wondering where I took inspiration for this dashboard, I added the image, and this dashboard is one of the ones showcased in the big book of dashboards. So this is the one that sort of inspired me to make this look as similar as possible to that one. In the background, I'm using that black. And for the colors of the charts, I'm using that green. And that's where I got the 3 big numbers idea. So here we're gonna set our theme again. And remember, you have to add it to the global options of bokeh, of holoviews with the render of bokeh. Now, to put it all together, so we had a couple of rows, a couple of columns in 3 rows. So column 1 contains all of the bands. It has a bit of a spacer, and then it has the table. The second column has the, excuse me, a row with the widgets and the whisker. So notice that how we can combine columns with a column, columns with a row, with a column, with a column, with a row. So that's the very first thing we talked about with panels. Panels, you can combine them all together. They can have multiple panels, they can have multiple widgets, and they can have multiple panes. And that's why they are so versatile. All right, so now we have our, actually, let's visualize all of these ones. We have our bands in our table. We have our widgets and our whisker. We have the combination of those two above. Remember that this one is difficult to see because it's all white, but once we fix the background, then it's completely going to change. And then in the next one, let's create the last row, the map and the dots. And now let's put it all together into a dashboard with a column, the title, and 2 rows. So 3 rows in total. We're going to give it a background color. And then that will not show because this is binder and we don't have that kind of permission. But now we get to plot our entire dashboard. So notice something up here. Notice how the ticks have now changed to yellow. Here they have changed to yellow as well. And now we have our dashboard. So notice what's happening. So we changed to apartment and everything is going to change here in a second. So notice how apartment is changing everywhere, especially in the map. Then we can still hover over the map and say, in Pittswater, the minimum price per stay is about $729. So remember, the minimum price per stay might be 10 days, it might be 15 days, it might be 5, it might be 2 nights for $600. In Stratfield, 405, seems cheap, 664 in Sydney. So imagine that the middle of the city is actually one of the most expensive places to stay at in Sydney. And then we can also hover over the reviews inside the dots plot, and we can change the net promoter to different ones. Notice how it changes this too. So the net promoter is connected to the whiskers and to the dots plot. The apartment is connected to all of them, or the property type is connected to all of them. All right, so we can save this one as an HTML file, as we did. And your task is, this one is actually fairly straightforward. You can use PN tabs to create 2 tabs, to create a representation of different tabs. So we have been using columns and rows so far, but let's actually work through it together. So we're going to do PN tabs, and we're going to say, we're going to take that dashboard, and we're going to take one of the other visualizations that we created. Let's see, what can we take? So let's take this ones, .1 and .2, just because. And we're going to come down here, and in the tabs, we're going to say, okay, so we want this dashboard here, and we want this other one here. We can use the Shift tab to see what is happening. So closable, dynamic, sizing, blah, blah, blah. There's quite a few options here, but if I am not mistaken, the way in which you assign a name to a tab is with a tuple, dashboard. And let's see, dots. Okay, so that should be loading. Awesome. So notice what just happened. So we have a full dashboard in one tab, but then at the top we have two tabs, dashboard and dots. So then if we go to dots, then we see just the dots in it. So we could have put absolutely anything on the second one. We could have put one dashboard, a second dashboard, a third dashboard, a fourth dashboard, and it would have been all fine in the tabs. So this is a very good representation, or a very useful tool if you need to show multiple views, especially if you host this as an app. So especially in that case. So what I can do is, I know we are past time, so I could show you, there is a notebook with the instructions on how to, I want to say, so the last notebook, yes. So this one is on how to share a dashboard. So I can show you, I can show all of you in about 5 minutes how to share a dashboard online. As a matter of fact, I do have one here, but I'm going to have to stop sharing this one and allow my, okay, here it is. Here it is. So I have my other, I am RP in the chat in my second computer. So let's see if I can take the screen sharing from mine so that I can show everyone how to share a dashboard. Perry, are you able to make RP the host?
I can only co-host them, but do they need to upload something or? Oh,
No, that's my second computer, but
oh, I
because,
see. Okay.
yeah, that's where I have actually the all the work at.
Okay, great. It's now been co-hosted.
Awesome. I see it now.
Mhm.
Perfect. I'm about to share my screen. So. Okay, so I am in my personal computer, or my other personal computer. And here I have the interactive, I don't know why I have that name, Stackle. So the explanation actually, so the key point of launching an app is when you have a dashboard, when you have everything you need in that dashboard, what you need at the very end is something that says, so for example, all of you have a folder called deployment. In that folder called deployment, we're going to have the dashboard that we just built. And at the very end, what you need is servable. You need the dashboard tagged together with something called servable. But let me zoom in a little bit because I know it's a little bit difficult to read that. Now, you can also serve, so you can serve two things. You can serve a .py file, a .py file, or you can serve a notebook. This is the plain notebook that we just worked through, but without without all of the pros, without all of the explanations as to what is happening at every step of the way. At the very end of that notebook, panel will also search for something called servable. Now, how can we create an app that actually does get served? So let's see. I'm going to bring up my terminal. Actually, I can probably use the one from Jupyter Lab. So yeah, so let's use Jupyter Lab. Okay, so I'm in my folder and I want to serve my app. I want to know, I want to see it. I want to see what's up. So what I will do is I will navigate to my folder, notebooks, and I will go to deployment. And in deployment, now that I'm in deployment, notice that I have all of my files, test.ipynb, test.py, whatever, and the data sets. That's also important. You got to have the data sets in them. Otherwise, it's going to start searching through directories while it's trying to serve something in a local host. So what we use is we say panel, and we can say show, and we can call the name of the notebook that we are going to use or the .py file. In this case, I'm going to use the .py file, and then I'm going to switch it to another one. So that is in the first instance. So I'm going to start usage panel, info. Oh, oops, sorry. Conda, you gotta be in your environment as well. PyCon 21. Okay, so now I'm in my PyCon 21, and now panel show. Am I missing something here? Oh, it's not panel show. I'm sorry. The morning panel serve, not show. Panel serve. Okay, perfect. So now it says that there's a running server up here. And what I could do is let's open up Mozilla. And let's go to this local server. So there was a bit of an error here. Rows, dots, something cannot find widget or abbreviation. All right. So we will interrupt this one. Apparently there's a bit of hiccup on that one. So we're gonna serve the second one, the test.ipynb. Okay. So now let's check the host. We're gonna grab this URL at the very bottom. Then we're going to go to Mozilla Firefox. And if everything goes through correctly, it should give us no error here. And our application should appear. And nope, it appears that there is a bit of an error with ours, but the beauty of live coding. So let's see. Actually, cannot find widget or abbreviation for argument. R format. Abbreviation argument. P type. So what we're gonna say, let's walk through this one then. And so a couple of ways to serve something. One is you have to either have a .py or that IPyNB, and then at the very end of the notebook, you have to have something that says servable. When that says servable, and you go to the command line, you get to say, okay, this is what I'm using. This is what I want you to show. And then bokeh starts a server underneath the hood. When that happens, you have something that you can redirect to someone, or something that you can either open in your local network or open outside your local network. What does that happen? So we use panel serve, 2 dashes and address. We open it up to anyone. Like we make it completely open. And then we need to, if we want to share it in just our network, we don't need to use this part. But in my case, the times I've tried it, I've had to. So what is this? What is this doing? Allow WebSocket. So you're saying allow anyone to join in and see whatever is happening at this port. And after that, you're going to have your dashboard. And this is one command line. How do you get that? If you are in a Linux machine, you're going to have to use host-I. If you are on a Mac, you can use ipconfig get if adr and 0. And yeah, a question. So I get this error pass for bokeh server application does not exist. Media data asym python tutorials. Does an additional module need to be installed for that? No, I think the asym, the error there was actually with the path, and I'm not sure like what the error I'm getting. I didn't really stop to like look at value error, cannot find the widget or abbreviation for argument. And a format name, line 242, 241. There's not even 241. No problem. I think the issue with this one, I want to say, is that you have to be in the same folder, or the data has to be in the same folder. And I'm going to try one last thing, but I don't have high hopes for that one. All right, so let's see. Oop, I have an issue with one of my widgets. All right, so read over this. Sorry, this part. At the very bottom, I actually put the detailed steps on how to get it done, how to get it working for you. So make sure you read over this. I know we're past time by quite a few minutes, so please send me any questions you might have as you go through the tutorial on your own. Yeah, thank you so much for coming.
All right. Thank you, everyone, for joining us here today. And thank you, Ramon, too, for that excellent presentation. We do appreciate your staying with us to discuss that. Feel free to join us later at the Hublot platform for anyone who wants to continue on with the discussion or just to network. Just go ahead and follow the instructions there in the chat. And this presentation has been recorded. Once it does get processed by the PyCon group, I'm sure they'll be sending out some email as to how to browse that on YouTube. So just stay tuned for that. All right. Other than that, let's take a look and see if there are any other remaining questions in our chat room before we close up shop. Let's see. We'll wait another minute, see if anything else comes in. Other than that, that's it. By the way, Ramon, could you let us know how may we connect with you through social networking? Do you have either a LinkedIn or anything like that?
Yeah, that'll be awesome. So my LinkedIn is Ramon PRZ01, and that's the only social media I have.
Perfect.
Yeah, and then if anyone has any questions after the tutorial, I put my handle for LinkedIn. So LinkedIn/that Ramon PRZ01, and then my email is I also put it there, Ramon PZ Jet G at protonmail.com.
Excellent. Well, thank you very much for that information. I don't see any other questions. Feel free to connect with us in the lounge if anyone has any additional things to discuss. Have a good day or night, depending on where you are. Take care, everyone.
Awesome. Thank you very much. Everyone have a great rest of your day. See you.
Bye.